There are turning points in the story of life, moments so violent, so improbable, so cataclysmic that they slice time into a before and an after. And for humanity, one of those moments happened roughly 74,000 years ago, when the sky over Earth darkened, the oceans cooled, and the future of our species narrowed to a razor's edge. In this opening chapter, we step into an age long before pyramids, before writing, before even the first sparks of civilization. Humanity existed only as scattered bands of hunter-gatherers stretched thin across an unforgiving world. We were not yet the rulers of the planet. We were one species among many, fragile and unremarkable, just another primate fighting for survival. But something was coming, something that would burn itself into the genetic memory of our species, a catastrophe so immense that scientists still struggle to comprehend its scale. It would reshape climates, redraw ecosystems, and compress human evolution into a bottleneck so tight we nearly vanished. That event was the eruption of Mount Toba, a volcano located on the island of Sumatra. Calling it an eruption almost feels like an understatement. Toba didn't merely explode, it detonated, releasing more than 2,800 cubic kilometers of ash and debris into the atmosphere. For comparison, this was more than 5,000 times the size of the Mount St. Helens eruption and dozens of times larger than Krakatoa. Across the globe, layers of ash would eventually settle as silent witnesses of the moment the earth itself screamed. Imagine standing somewhere in East Africa, one of the homelands of early Homo sapiens, and noticing a strange haze creeping across the sky. It thickens over days, then weeks. The sun dims, the temperature begins to drop, the rains change, seasons shift out of rhythm, migratory animals disappear. The natural world grows unstable, and with every passing year, food becomes harder to find. This wasn't simply a bad season, it was a volcanic winter. Some scientists believe temperatures around the world may have plunged by several degrees, enough to trigger decades of famine-like conditions. For a species that lived day to day, dependent on fresh plants, migrating herds, and predictable weather, this was nothing less than a death sentence. And yet, we survived. But here is the startling twist. We may have survived in numbers so small, they could fit inside a modern stadium. This is where the story turns from geology to genetics, from ash clouds to DNA. When researchers study the genetic diversity of modern humans, they find something odd, something almost uncanny. Compared to other primates, even compared to many animals, humans are genetically narrow. Almost as if at some point our species was squeezed through a narrow doorway, losing enormous genetic variation along the way. That doorway, many think, was Toba. The hypothesis isn't without debate. Some scientists argue the bottleneck was real but unrelated to the eruption. Others argue the Toba event wasn't globally catastrophic, yet the timing is suspicious, almost too perfect. Around 74,000 years ago, modern humans show signs of drastic population reduction, followed, mysteriously, by a long period of evolutionary stagnation. This is where our story begins to unravel a deeper mystery, because after Toba, after this supposed bottleneck, something unusual happens in the evolutionary record. Physical changes in humans slow dramatically. Our anatomy stabilizes. Our brain size plateaus. The major pressures that once shaped our species seem to quiet down. Evolution doesn't stop, but it changes its rhythm. It becomes quieter, less visible, more subtle. It's as if the Toba catastrophe froze the trajectory of our biological evolution and forced humanity onto a new path. A path where survival depended less on biology and more on culture, on language, on cooperation, on innovation. But to understand why this happened, we must first understand the magnitude of the event itself. So picture it again. Earth, dim and cold, cloaked in volcanic ash for years, maybe decades. The sky the color of metal, the winds carrying fine dust that settles like gray snow, plants withering, animals migrating or dying, and scattered across vast continents, tiny groups of humans, each struggling to see the next sunrise. Was this the moment when evolution paused? Was this the crucible that forced Homo sapiens to reinvent themselves, not through genes but through ingenuity? No one can say for certain. But genetic traces hint at a bottleneck so extreme it's almost miraculous we made it through at all. And the greatest mysteries of our species, our intelligence, our adaptability, our creativity, may have been shaped by those years in the dark. Because when nature collapses around you, you either change or you vanish. Humanity chose to change, but how that transformation unfolded and why it didn't reshape our bodies the way previous pressures had is a question we'll explore step by step. For now, we stand at the edge of the Toba eruption, staring into a world on the brink of extinction, a world where every human life is a flickering ember in a storm. And yet, against all odds, that ember refused to die. But what came next would change everything, and so it did. As the ash clouds from Toba continued to drift around the planet, the consequences grew more profound than any living creature could comprehend. For humans, already a young species navigating a harsh landscape, this was not just a climate crisis. It was a crucible, and what emerged from that crucible would define the very blueprint of modern humanity. To understand how, we must shift from the dramatic violence of the eruption to the quiet, invisible world inside every human cell. Because the true story of why humans stopped evolving in the obvious, physical ways begins with what Toba did to our genetic diversity. When scientists examine the DNA of living humans, they find something startling. We are shockingly similar to one another, not just in appearance or behavior, but in the very architecture of our genome. In fact, humans are far less genetically diverse than chimpanzees, orangutans, or even some isolated species of animals with much smaller populations. It's almost as if, at some point, our species passed through a narrow gate, one that squeezed the genetic variation out of us and left only a few surviving lines. This is known as a genetic bottleneck, and while the Toba event isn't universally accepted as the cause, the timing is too compelling to ignore. Imagine global human populations shrinking from tens of thousands to perhaps a few thousand. Some estimates argue even fewer. That means entire communities vanished. Bloodlines disappeared. Genetic branches that might have led to entirely different versions of us were abruptly cut off. Human evolution didn't stop, but the range of possibilities drastically narrowed. Picture a lush forest reduced to a handful of seeds. The forest can regrow, but it can never again hold all the diversity it once had. The human story, after Toba, became the story of those few surviving seeds. This is why all modern humans, whether from Africa, Asia, Europe, or the Americas, share a remarkably tight genetic profile. A Maasai herder, a Japanese fisherman, a Peruvian farmer, and a Scandinavian engineer all carry DNA far more similar than you might expect. We appear diverse in language, culture, and appearance, but genetically we are almost clones compared to many animal species. Why did this bottleneck matter? Because evolution feeds on variation. The more genetic options a species has, the more paths evolution can explore. When variation shrinks, evolution slows. Not because the forces of nature have ceased to act, but because the raw material they work with becomes limited. After Toba, evolution didn't have the same palette of possibilities. The canvas became smaller, yet there was another consequence, one even more significant. When populations shrink, cultural knowledge becomes fragile. Traditions, innovations, and techniques can vanish simply because the last person who practiced them dies. But in some pockets of humanity, something else happened. Instead of collapsing into silence, some groups began relying more heavily on cooperation, communication, and shared wisdom. And this is where the story begins to shift, because while biological evolution slowed, cultural evolution began to accelerate. But before we explore that revolution, let's linger for a moment in the aftermath of Toba. Imagine a world where the climate is unpredictable, where game animals are scarce, where plant life grows erratically, where storms and droughts alternate with no pattern. In such a world, survival doesn't depend on superior muscles or sharper teeth. It depends on something else entirely. It depends on planning, on foresight, on communication, on social bonds. A lone human in this environment stands no chance. A coordinated group, however, one with the ability to strategize, teach, and innovate, can endure even in the harshest conditions. And so the bottleneck didn't simply reduce our numbers. It pressured the survivors towards specific kinds of behavior: cooperative behavior, symbolic thinking, creativity, storytelling, memory, traits that weren't strictly biological but were far more flexible, far more powerful. As the volcanic winter dragged on, humans who could share knowledge had a higher chance of survival. Those who could read subtle signs in the landscape, who could adapt their tools, who could communicate danger or opportunity. Those were the individuals who gave their groups an advantage, not because they were biologically superior, but because they were cognitively adaptable. This is the beginning of the shift that would define the future of our species. Culture started replacing biology as the main engine of adaptation. Natural selection didn't disappear, but it softened. The pressures that once rewarded physical robustness were now overshadowed by pressures that rewarded cooperation and intelligence. And slowly, as the climate stabilized and humans began to recover, the stage was set for something extraordinary. Something that the bottleneck may have delayed, but also, in a strange paradox, made inevitable. Because somewhere between 70,000 and 50,000 years ago, humans experienced what researchers call the cognitive revolution, the dawn of complex language, symbolic art, long-distance trade, and tools that reflected not just survival, but imagination. It was the moment when we began shaping the world, instead of being shaped by it. But before that revolution could ignite, humanity had to pass through the narrow gate, through the ash-filled decades when our future balanced on a knife's edge. In those years, evolution didn't stop. It simply changed direction. And the next stage of that transformation, the birth of our unique mind, is what awaits us next. Because the bottleneck created a silence in the genetic record, but in that silence, something remarkable began to stir. And now we step into one of the most mysterious chapters in the entire story of our species, the moment when the human mind ignited. To understand why humans stopped evolving in the obvious anatomical sense around 70,000 years ago, we must look not at bones or fossils, but at the invisible revolution that unfolded inside the skull. A revolution in thought, imagination, and communication. A transformation so powerful that it would overshadow every biological change that came before it. Welcome to the cognitive revolution. It wasn't a single event. It wasn't a sudden mutation or a flash of lightning. It was a gradual awakening, one that happened over thousands of years, but so dramatically altered human behavior that in hindsight, it looks like evolution hit a switch. Something changed in the way humans processed the world. Something changed in the way we spoke, remembered, created, imagined, and understood one another. But what was it? To answer that, let's return to the world just after the Toba bottleneck. Cold, unpredictable, and painfully fragile. Our ancestors, scattered across Africa and parts of Eurasia, faced a brutal reality. Nature was no longer generous. Food was scarce. Climates shifted without warning. Predators flourished while prey dwindled, and human populations, still minuscule, hovered on the brink of extinction. In such an unforgiving landscape, physical strength alone meant little. Speed, muscles, teeth, claws, none of it could compete with the sheer scale of environmental instability. What mattered now was something subtler, more flexible, more adaptive. What mattered was thinking ahead. Imagine trying to survive in a world where a sudden temperature drop could kill your plants, where a failed hunt could mean starvation, where storms could wipe out your shelter, where neighboring bands could hold crucial information you desperately needed. The groups that survived weren't the strongest. They were the most mentally adaptable. They were the ones who shared ideas, analyzed patterns, planned migrations, rationed food, and created stories that carried warnings and lessons across generations. These weren't genetic adaptations. They were cultural adaptations, and they were far more powerful. It is here that language begins to emerge. Not just simple signals or shouts, but complex, symbolic language capable of expressing ideas that didn't exist in the present moment. Imagine the leap that required. For the first time, humans could speak of things not in view, danger beyond the hill, prey that migrated last season, strategies for the next hunt. They could share memories. They could picture the future. They could imagine things that had never yet existed. This ability to think symbolically, to create mental maps of the world, was a superpower no other species had developed at this scale. And it didn't just help us survive. It changed the entire trajectory of our evolution. Consider this. Once humans could communicate complex ideas, innovation accelerated. A tool wasn't just an object. You could teach someone else how to make it. A successful strategy wasn't a secret. It became a shared memory. And once knowledge became transmissible, culture became the new engine of adaptation. Until this point, evolution worked slowly, sculpting the body through tens of thousands of generations. But now, humans could adapt within a single lifetime, not because their bones changed, but because their minds did. A child born into a group with stories about surviving harsh winters had a higher chance of surviving one. A hunter taught to use a tool refined across generations would outperform any untrained competitor. A community with rituals and shared symbols could cooperate on a scale no animal could match. Evolution no longer needed to shape our bodies because culture did the shaping for it. This was the moment when biology stepped back and narrative stepped forward. Yet the cognitive revolution remains one of the greatest puzzles in science. How did it happen? Why did it happen when it did? And why did evolution, physical evolution, seem to slow dramatically afterward? Some theories point to neurological changes, small shifts in the wiring of the brain that allowed for symbolic thought or enhanced memory. Others suggest that once language reached a certain threshold, complex cognition unfolded naturally, like a chain reaction. Some researchers even argue that the Toba bottleneck itself may have played a silent role, because small populations have an easier time spreading beneficial innovations rapidly. Once one mind sparks, the flame spreads quickly. But whatever the cause, the effect was undeniable. Around 70 to 50,000 years ago, humans began doing things no species had ever done before. They carved figurines. They painted in caves. They buried their dead with ritual objects. They crossed oceans to settle new lands. They created tools that were not merely functional but carefully crafted. Spears balanced for distance throws, blades shaped with precision, ornaments symbolic rather than practical. This wasn't just intelligence, it was imagination. It was creativity. It was the birth of human culture. And once it began, evolution entered a new era, an era where our survival would depend not on the slow work of genes, but on the fast work of ideas. Because ideas could evolve faster than biology, language could change faster than DNA. Tools, strategies, myths, and symbols could transform entire societies in the span of one lifetime. Evolution didn't stop. It simply changed battlefield. This is the threshold we cross now. The moment when humanity became something unprecedented, a creature shaped not just by nature but by its own mind. But there is another twist to this story. Because even as culture began to ascend, something else was happening in the background. Something that would further weaken the old pressures of natural selection and reinforce the dominance of cultural evolution over biological evolution. It has to do with cooperation, safety, and the end of brutal environmental filters that had once sculpted our bodies. And that is where our journey leads next, because the rise of the human mind was only the beginning, and what followed would redefine what it means to evolve. With the dawn of symbolic language and complex thinking, humanity stepped into a new chapter, one in which our brains became our greatest survival tool. But there's a deeper layer to this transformation, one that shaped the very question at the heart of this documentary. Why did humans stop evolving physically around 70,000 years ago? Why did our bodies stabilize? Why did our anatomy remain essentially unchanged while our culture exploded into boundless complexity? To find the answer, we must explore what happened as humans gained new forms of control over the environment. This is the chapter where natural selection, once the ruthless sculptor of our species, began to lose its grip. Before the cognitive revolution, survival was brutal. Nature was unforgiving, predators relentless, weather unpredictable. Only the strongest, fastest, best adapted individuals survived to pass on their genes. Evolution worked like a grinder, constantly shaping and reshaping the bodies of early humans. But after the bottleneck, something shifted. Humans began creating buffers between themselves and the chaotic forces of nature. Buffers made not of bone or muscle, but of cooperation, planning, and innovation. Let's break down how these buffers changed the rules of evolution. 1. Cooperation became a survival strategy. Before, if an individual was weak, sick, injured, or slow, nature removed them from the gene pool. But as humans formed tighter, more cooperative groups, united by shared language and shared stories, that brutal filter weakened. A child with poor eyesight could survive if their community protected them. An injured hunter could still contribute through storytelling or tool-making. A mother with limited physical endurance could still help raise children or manage food preparation. This shift is monumental. It meant that physical traits were no longer the decisive factor in survival. Those who might have been eliminated by nature in earlier eras now lived long enough to reproduce. This softening of natural selection is one of the key reasons human evolution began to slow, not because biological evolution stopped, but because the old pressures stopped killing off genetic variety. 2. Tools replaced biological adaptations. Our ancestors once adapted biologically to their environment, but after the cognitive revolution, tools began doing that job for us. Need sharper claws, make a spear, need thick fur, sew clothing, need stronger jaws, cook food until it's soft. Need night vision, create fire, and light up the darkness. Suddenly, the body didn't need to evolve for survival because the mind could invent solutions at a pace far faster than biological evolution could ever match. This single shift, technology replacing biology, is one of the most important events in the entire history of life. No other species offloads biological work onto culture. Evolution is slow. Tool-making is immediate. Why grow stronger muscles over 10,000 years when you can build a better tool in an afternoon? 3. Fire, shelter, and clothing created environmental neutrality. For millions of years, early humans evolved to survive specific climates. Thick hair, thin hair, tall bodies, compact bodies. These traits reflected ecological pressures. But once you can control fire, build shelters, and wrap your body in furs, climate becomes less relevant. You don't need a cold-resistant body when you have warm clothing. You don't need heat-resistant skin when you build shaded structures. This dramatically reduced the role of climate as an evolutionary sculptor. Nature lost another tool for shaping us. 4. Long childhoods and extended lifespans. Changed selection. Pressures complex societies require deep learning. You need time to absorb stories, language, hunting strategies, social rules, tool-making techniques. Children who could absorb information and who grew up in stable communities where adults protected them had better outcomes. But here's the twist. Long childhoods also mean less biological pressure on early physical maturity, shifting evolution toward cognitive development rather than muscular or anatomical changes. Humans began evolving for learning, not for brute strength. This emphasis on learning fueled culture, which in turn replaced the need for biological adaptation even more. 5. Safety nets weakened death as a selective force. When life is safer, natural selection slows. When threats diminish, selective pressures relax. Consider the innovations stacking up: cooperative hunting, shared childcare, food storage, planned migrations, shelters, fire, protective clothing, early medicine, communal defense. With each innovation, humans became less vulnerable to starvation, exposure, predators, and disease. That meant fewer traits were being aggressively filtered out by nature. More people survived. More genes persisted. Evolution's violent pruning slowed. The paradox of human evolution. By creating tools and culture, humans accidentally built a world where biological evolution struggled to keep up. Because what shapes a species more, cold winters, or the invention of clothing, dangerous predators, or the creation of weapons, scarcity of food, or the ability to plan for next season? Evolution didn't stop. It simply lost its urgency. Nature wasn't in charge anymore. Humans were. The stabilization of human anatomy. By around 70,000 years ago, Homo sapiens looked essentially like we do today. Our brain size had plateaued. Our body proportions stabilized. Our facial structure settled into its modern form. We didn't need new physical adaptations because we had invented something far more powerful: adaptability itself. The moment humans could reshape the world instead of being shaped by it, physical evolution no longer had the same job. Culture took the lead, the next step in the story. But this raises a new question, one even more perplexing. If cultural evolution replaced biological evolution, what happened next? What did humans do with this newfound power? How did it change our path through prehistory? And how did it set the stage for the next great leap, the one that would carry us across continents and into the future? To answer these questions, we now turn to the event that truly transformed humanity into the species we recognize today, a moment when our ancestors began not just to survive, but to imagine new worlds. Because after nature stopped shaping us, humans began shaping themselves, and what happened next would unfold on a global scale. We now stand at the threshold of one of the most extraordinary transformations in the entire history of our species. The moment humans began leaving Africa, spreading across continents, and taking command of the earth itself. This migration, this expansion, was not the first attempt by human ancestors to leave the continent, but it was the first time our kind, Homo sapiens, ventured outward not as vulnerable wanderers, but as cognitively advanced, culturally equipped, and fully modern humans. And it is here, in this global dispersal, that we find key clues to another question at the heart of this story. If human physical evolution slowed down, why didn't it completely stop? Why do we still see genetic differences between populations today? To answer that, we need to understand what the Great Expansion truly was. Not just a migration, but a colossal evolutionary experiment played out across the entire planet. The world opens before us. The date is somewhere between 70,000 and 60,000 years ago. A small group of humans, possibly a few hundred, possibly a few thousand, begins moving along the coasts of the Arabian Peninsula, following shorelines rich in fish, shellfish, and other resources. Unlike earlier hominins, these humans had the technological flexibility to survive almost anywhere. They possessed language, cooperative hunting strategies, and the ability to innovate rapidly when facing new environments. They didn't need to wait for their bodies to evolve to suit new landscapes. They carried adaptation in their minds. And so they walked north into the Levant, east into Arabia, across India into Southeast Asia, down into Australia, north again into Siberia, across the land bridge into the Americas. A journey that would take tens of thousands of years. A journey that would reshape ecosystems, drive other hominin species to extinction, and cement Homo sapiens as the dominant force on Earth. But behind this triumph lies a contradiction. If humans were so mentally adaptable and cultural evolution was so powerful, why did physical evolution not stop entirely? Why do people from different regions still exhibit distinct physical traits? Skin color, height variations, lactose tolerance, disease resistance, high-altitude adaptations, heat tolerance, cold tolerance. Clearly, evolution was still at work, but the nature of that evolution had changed. soft pressures, sharp differences. When humans spread across the planet, they encountered environments vastly different from anything in Africa. Arctic tundras, harsh deserts, high-altitude plateaus, dense rainforests, seasonal climates with extreme winters, tropical regions with heavy pathogen loads. These environments created new pressures, but far softer than the brutal pressures that shaped our early ancestors. Why softer? Because culture provided a shield. Fire, clothing, tools, shelters, and social cooperation prevented these pressures from killing off large numbers of people. Instead, they worked slowly, influencing small changes over long stretches of time. This is why modern human differences are subtle, not dramatic. Neanderthals evolved massive brows, huge rib cages, and enormous bodies to survive the cold. Homo sapiens, we invented tailored clothing and kept our anatomy relatively unchanged. The difference is profound. Culture didn't eliminate evolution. It merely redirected it and slowed it. That's why post-bottleneck evolution looks like a series of fine adjustments rather than major redesigns. Skin color, the most misunderstood adaptation. One of the clearest examples of post-expansion evolution is skin pigmentation. As humans moved into regions with lower UV radiation, dark skin, an adaptation vital in equatorial Africa, became less necessary. Over tens of thousands of years, mutations that lightened skin spread because they helped the body produce enough vitamin D in sunlight-deficient regions. But once again, culture complicated the picture. In some places, diet provided the missing vitamin D, meaning dark-skinned populations could thrive even in low UV regions without evolving lighter skin. In others, cultural behaviors, like clothing or shelter, affected UV exposure. Skin color evolution shows us that biology was still at work, but working slowly and always in conversation with culture. Lactose tolerance, evolution continues to whisper. Another example, lactase persistence, the ability to digest milk as an adult. This mutation spread only in populations that practiced animal domestication. Where dairy wasn't culturally important, the mutation didn't spread. Where dairy became a crucial food source during famines, it exploded. This is the perfect illustration of the new evolutionary landscape. Biology doesn't lead. Culture leads. Biology follows. High altitude. Evolution. Takes a deep breath. In the Tibetan Plateau, the Ethiopian highlands, and the Andes, different human populations adapted independently to survive low-oxygen environments. Even though their bodies look nearly identical on the surface, their genetic solutions differ, their cultures differ, their histories differ, but each one shows the same principle. Small, targeted evolutionary tweaks, not sweeping anatomical transformations. This is the new tempo of human evolution, the paradox of diversity and uniformity. Here lies one of the great paradoxes of our species. Humans are extraordinarily geographically widespread, yet biologically uniform. We look different, yet genetically similar. We adapted physically, yet preserved our essential anatomy. We evolved, yet evolution slowed. This paradox only makes sense when you understand the truth. Cultural evolution became the dominant force, and biological evolution became its shadow. Genes still changed, but only where culture and environment allowed it. Traits still evolved, but subtly, not radically. Pressures still existed, but they nudged instead of sculpting. And so the Great Expansion wasn't just a journey across continents. It was the moment when evolution lost its monopoly on adaptation, and culture took the wheel. The next step in the story. Now that humanity had spread across the world, something else began to unfold. Something that would accelerate this separation between biology and culture even further. Something that transformed survival itself. the rise of complex societies, trade networks, symbolic art, communal rituals, and shared mythologies. Because once humans not only migrated but built civilizations, the pressures shaping us changed again, this time in ways evolution had never encountered before. And what happened next would take humanity from scattered nomads to world-shaping architects of their own destiny. With humans now spread across nearly every reachable corner of the Earth, the stage was set for the next colossal turning point in our evolutionary story, one that would accelerate cultural change so dramatically that biological evolution would slip even further into the background. This turning point wasn't a tool. It wasn't a mutation. It wasn't even a discovery. It was something far more powerful, the formation of stable, organized human societies. For millions of years, humans lived in small bands, 20 to 50 individuals at most. These groups were fluid, mobile, and precarious. Children grew up exposed to constant danger. Adults were vulnerable to injury, starvation, and conflict. Knowledge could vanish with the death of a single storyteller. But somewhere around 50,000 to 40,000 years ago, something profound shifted. Humans began forming larger, more complex communities, weaving together families, kin groups, and alliances into a tapestry of early society. This was the moment when culture gained enough momentum to eclipse biology completely. To understand how and why, we must step into the heart of this transformation, the power of shared imagination. Every society, ancient or modern, rests on one invisible foundation: shared beliefs. Not just beliefs about the physical world, but about rules, relationships, cooperation, and meaning. This is where symbolic thinking, born during the cognitive revolution, reached its full flowering. Humans began creating myths, rituals, laws, norms, roles, taboos, hierarchies, identities. These weren't simply cultural features. They were survival strategies. For the first time in history, a human being didn't survive because they were physically adapted to their environment. They survived because they belonged. Membership became the strongest evolutionary advantage. A newborn in a strong community had a better chance of survival than the strongest hunter wandering alone. A mediocre hunter could still live a long life if their society provided for them. A person with limited physical abilities could become invaluable as a storyteller, healer, ritual leader, craftsperson, or strategist. Natural selection wasn't gone, but it had been reshaped. Strength mattered less. Skill mattered more. Intelligence, memory, empathy, persuasion, creativity, and social intuition became essential survival traits. Biology started to fall silent. Culture began to speak loudly. The first cultural ecosystems. As communities grew, something extraordinary happened. They formed cultural ecosystems, vast networks of shared knowledge that no single individual could hold alone. Consider what daily life required: knowledge of edible plants, tracking techniques, weather patterns, migration cycles, tool making, fire maintenance, social rules, healing practices, conflict resolution, spiritual rites, storytelling techniques. This collective knowledge was far richer than anything biological inheritance could provide. A child didn't need to evolve sharper instincts. They needed access to culture. And culture spread faster than genes ever could. A useful idea could transform an entire community in a single season. A life-saving technique could spread across tribes within a few generations. A ritual could unify dozens of families into a cohesive society. Evolution had never seen anything like this. It was as if the species had invented a second genome, made not of DNA but of information. While DNA took thousands of years to change, culture adapted overnight. This imbalance changed everything. The rise of specialists. As societies grew in size and complexity, they gained another advantage unknown to earlier humans: specialization. Most animals and early hominins were generalists. They had to hunt, gather, fight, heal, navigate, teach, and protect all at once. But in larger human groups, some became expert toolmakers, some became expert trackers, some became ritual leaders, some became healers, Some became negotiators, some became artists, some became guardians, some became explorers. For the first time, human communities weren't collections of individuals. They were systems, each member supporting roles that benefited the whole, and systems can outcompete individuals. This shift created enormous buffers against death and misfortune, weakening natural selection even more. Biological traits that might have doomed a person in earlier eras were now neutral or even irrelevant. A physically fragile individual could excel in memory-based roles. A slow runner could be a brilliant strategist. A poor hunter could be a skilled craftsman, raising the entire community's chances of survival. Now imagine what evolution looks like under these conditions. It doesn't disappear. It diffuses. It becomes subtle, softer, slower. Biology no longer needs to redesign the body when culture already provides the tools. The control of death. One of the greatest forces shaping evolution is death, specifically who dies young and who survives to pass on their genes. But as societies grew, death itself became less selective. Tools reduced hunting accidents. Cooperation reduced starvation. Shelters protected against the elements. Group defense reduced predator attacks. Rituals mediated conflict. Knowledge increased survival rates for childbirth and injury. Every improvement in safety further weakened natural selection. If death is the sculptor of evolution, then society dulled its blade, and something extraordinary followed. Humans began living long enough to accumulate wisdom, passing it down through generations. This long memory became another cultural superpower and another shield against evolutionary pressures. The first networks of trade and exchange. Around 45,000 years ago, evidence of long-distance trade emerges. Obsidian moving hundreds of miles, shells traded far from the coast, pigments shared between distant groups. These exchanges were not merely economic. They carried stories, ideas, rituals, and technology. Trade networks linked human groups into something evolution had never anticipated, a species-wide information web. The more connected humans became, the faster ideas evolved, and the less biology needed to change. Because as long as culture could adapt quickly, the body didn't have to. A new evolutionary rule emerges. For millions of years, evolution followed a simple logic. Adapt your body to survive. But after the rise of society, the rule changed. Adapt your mind. Adapt your culture. Your body can remain the same. This is the critical turning point that answers our central question. Humans didn't stop evolving. Humans changed how they evolved. We evolved culturally, not physically. We evolved through knowledge, not anatomy. We evolved through cooperation, not muscle. We evolved through imagination, not instinct. This is the shift that explains why our bodies stabilized 70,000 years ago, yet our world changed beyond anything nature had ever produced. But this story is far from over, because the next great transformation would supercharge cultural evolution to unimaginable levels and push biological evolution even further into the background. A transformation born not of survival, but of abundance. Because after society formed, humans began to re-engineer the landscape, and what came next reshaped the destiny of our species forever. Up until now, the story of humanity has been the story of mobility. We walked, wandered, followed the seasons, tracked herds, and drifted across continents like rivers of muscle and memory. Our survival depended on movement. The world was our map, and food was the compass that never stopped spinning. But somewhere around 12,000 years ago, something happened that would freeze that compass in place. Humans stopped wandering. We planted our feet and our seeds in the soil. This moment, known as the agricultural revolution, is one of the most important turning points in the history of life on Earth. Not because it made human life easier. At first it didn't. Not because it was inevitable. It wasn't. And not because it brought immediate benefits. Those would come much later. Its importance lies in something far deeper. Agriculture permanently changed the relationship between humans and nature. For the first time, we weren't adapting to the environment. We were reshaping it. to adapt to us. And in doing so, we pushed biological evolution even further into the shadows. The great gamble agriculture wasn't a simple invention. It was a gamble, a risky experimental leap taken by communities under pressure. As the last ice age ended, climate patterns shifted dramatically. Resources shifted too. Some regions saw wild cereals flourish, others saw megafauna decline. Human groups, now growing in number and social complexity, faced a choice: adapt to shrinking mobility or reinvent how food was obtained. And so small groups began experimenting with planting seeds intentionally, watering patches of wild grains, storing harvests, protecting certain areas from grazing animals. These were not farms yet. They were experiments. But experiments, like sparks, can become wildfires when conditions are right. Over generations, what began as small-scale maintenance became structured cultivation. Cultivation became dependence. Dependence became civilization. And civilization changed the meaning of evolution. The first permanent settlements. When humans settled down, everything changed. Movement no longer dictated social structure. Seasons no longer dictated migration. Food no longer came from the wild. It came from human hands. This stability brought profound consequences. Villages formed around fertile land. Homes were built. Tools specialized. Roles multiplied. Knowledge deepened. Population expanded. But something else happened, too. Something subtle, yet deeply significant. The environment stopped killing humans at the same rate. Nature's brutal filtering weakened even more. Food storage reduced starvation. Grain cultivation created predictability. Communities protected their vulnerable members. Medicine, rudimentary but real, became part of daily life. Suddenly, the survival of a child depended less on physical traits and more on cultural membership. Biology drifted further into the background. Culture surged forward, the price of abundance. Yet agriculture came at a cost. For the first time, humans created crowded communities, and with them, new pressures. Disease spread more easily. Diets became less diverse. Work became harder and more repetitive. Social inequality emerged. Conflict over land increased. Ironically, early farmers were less healthy than hunter-gatherers. Their bones show malnutrition, dental decay, and signs of chronic labor. But here is the twist. These new pressures did not reshape human anatomy in the way ancient pressures once did. Why? Because culture intervened again. Sick individuals were often cared for. Disease led to herbal remedies and rituals. Food shortages encouraged storage and community sharing. Conflict created social rules, alliances, and leadership systems. Cities built walls, drainage systems, and early sanitation. Every challenge agriculture introduced, culture countered. Biology didn't need to evolve new defenses because ideas evolved faster. The agricultural revolution was not a story of genetic transformation. It was a story of cultural hyper-acceleration, the birth of domestication and coevolution. But while humans stopped evolving physically at fast speeds, something fascinating was happening around us. The plants and animals we touched evolved dramatically and quickly. Wild aurochs became cattle, wolves became dogs, wild teosinte became corn, bitter almonds became sweet almonds. Wild rice diversified into dozens of regional variants. In other words, humans paused their own physical evolution and became the evolutionary engine for everything around them. We became not products of evolution, but creators of it. And yet, as we shaped plants and animals, we weren't evolving into something radically different ourselves. Our anatomy stayed largely the same. Our brain shape didn't change. Our height fluctuated but normalized. Our features remained consistent. Instead of us evolving into better farmers, we made farming evolve for us. The power dynamics had reversed. Nature no longer sculpted humans. Humans sculpted nature. Population explosion, evolution's softening continues. Agriculture created a food surplus. Surplus created population growth. Population growth created even more buffering against natural selection. In small groups, a single death can reshape a gene pool. In large populations, death loses its evolutionary weight. Early agricultural communities grew into thousands. Thousands grew into tens of thousands. Tens of thousands grew into cities. The implications for evolution were enormous. Random genetic drift weakened. Harmful mutations could survive. Beneficial mutations spread more slowly. Physical adaptation was less urgent. Cultural innovation outweighed genetic variation. Imagine evolution as a sculptor, once wielding a chisel, now holding a feather. The pressures that shaped earlier hominins, starvation, predators, competition, exposure, were now dampened by granaries, walls, rituals, organization, division of labor, communal parenting, medicine, sanitation, trade. Human evolution didn't stop. It simmered quietly while culture exploded violently. The first cities and the end of primitive evolution. By the time the first great cities arose, Çatalhöyük, Jericho, Uruk, Memphis, evolutionary pressures had been transformed entirely. People lived in dense, crowded settlements where ideas traveled faster than genes. Tools changed faster than anatomy. Social rules replaced instinctive behavior. Governance replaced raw strength. Written language began to preserve knowledge beyond the lifespan of any individual. In earlier ages, evolution chose winners through physical survival. Now, survival depended on belonging to systems far larger than the individual. And with this shift, biological evolution slowed to a crawl. Not because nature gave up, but because humans had created a world where knowledge and cooperation were the primary survival traits. Yet something else was happening too, something easy to overlook but critical to our story. While evolution slowed at the surface, it began bubbling beneath it in subtle ways. Small adaptations, quiet mutations, regional differences, disease resistance, dietary changes, metabolic adjustments, high-altitude tolerance. Evolution didn't stop. It changed rhythms, from a roaring fire to glowing embers, and the next block will uncover these embers in detail, because even in the age of agriculture and civilization, evolution still whispered, reshaping us in ways we barely notice. And those whispers would eventually become the foundation of our modern biological diversity. We've now journeyed through the great turning points that slowed the dramatic, visible changes in human evolution. But slowing is not the same as stopping. Even as culture became the dominant survival tool, even as cooperation, identity, and innovation replaced teeth, sinew, and instinct, human biology continued to shift, quietly, subtly, almost imperceptibly. In this chapter, we explore the hidden side of human evolution, the mutations that continued shaping us long after natural selection lost its brutal edge. Because while the agricultural revolution softened nature's hand, it also introduced new pressures, new environments, and new challenges that whispered their influence into our DNA. This is the story of how evolution adapted to a world shaped by humans, of how biology responded to culture, the rise of diseases, a new evolutionary battlefield. As cities grew, populations clustered, and humans began living in tight spaces with domesticated animals, a new enemy emerged, one more relentless than cold winters or hungry predators: infectious disease. Before agriculture, diseases had difficulty spreading. Hunter-gatherer bands were too small and too scattered for most pathogens to survive long enough to become endemic. A deadly virus might wipe out a small group, but it would also die with them. But once humans clustered in villages, towns, and cities, everything changed. The first epidemics arrived: tuberculosis, cholera, malaria, smallpox, influenza. These weren't just threats, they were evolutionary filters. Communities constantly exposed to disease slowly accumulated mutations that offered resistance. The CCR5D32 mutation, for example, which provides partial resistance to HIV and possibly protected against earlier plagues, spread widely in certain populations, because those without it were more likely to perish during ancient disease outbreaks. Malaria, one of humanity's oldest killers, scholars, had an even more dramatic genetic impact. The sickle cell trait, a mutation deadly when inherited from both parents but beneficial in its heterozygous form, became more common in regions where malaria ravaged communities. Evolution rewarded a mutation that would be harmful under other circumstances. This is the paradox of post-agricultural evolution. Culture created the conditions for disease, and disease quietly sculpted our genes, not dramatically, not visibly, but unmistakably. The lactose revolution, when diet became destiny. Perhaps the most famous example of modern human evolution is the emergence of lactase persistence, the ability to digest lactose, the sugar found in milk, into adulthood. Until about 8,000 years ago, nearly all humans were lactose intolerant. The gene that produced lactase, a digestive enzyme, shut off after childhood because there was no evolutionary advantage in digesting milk once a child was weaned. But then came domestication, then came cattle, then came dairy. Milk became a calorie-rich, stable, year-round food source, especially important during famine or seasonal scarcity. Those who could digest it had an advantage. Those who couldn't, they survived too. The pressure wasn't deadly, but they were a little less nourished, a little more vulnerable. And over thousands of years, lactase persistence rose from nearly 0% in humans to more than 90% in certain populations. But here's the key lesson. This wasn't natural selection in its ancient, brutal form. This was soft selection, shaped by culture. Culture created dairy. Dairy created a new evolutionary pressure. Evolution responded. This dynamic, culture making the pressure, evolution adjusting to it, quietly rewrote the rules of our species. High altitude, the thin air adaptation. In the Himalayan plateau, the Andes, and the Ethiopian highlands, another remarkable evolutionary story unfolded. Living thousands of feet above sea level means chronic low oxygen. For most people, especially children, this environment is deadly. But for populations who settled these regions thousands of years ago, evolution provided subtle genetic solutions. Tibetan populations developed a unique version of the EPAS1 gene, inherited from a Denisovan ancestor, allowing their blood to absorb oxygen more efficiently without thickening dangerously. Andean highlanders evolved increased lung capacity and higher hemoglobin levels. Ethiopian groups developed yet another oxygen processing strategy, different from both Tibetans and Andeans. 3 populations, 3 evolutionary solutions. But again, the changes were subtle. No new species, no new body structures, just small tweaks that helped humans thrive in new environments created by human exploration. Evolution wasn't dead. It had simply shifted from a sculptor to a watchmaker, making precise adjustments instead of wholesale redesigns. Skin pigmentation, balancing light and life. We touched on this earlier, but now we explore the deeper evolutionary logic behind skin tone. Dark skin evolved in Africa to protect against intense UV radiation, a biological shield against DNA damage and folate depletion. But when humans migrated north, the environmental pressure flipped. UV levels dropped, vitamin D production fell. In these conditions, lighter skin helped maximize the limited sunlight. But skin color didn't evolve in isolation. Culture interfered again. Coastal diets rich in fish, like those in northern Asia, provided vitamin D, reducing pressure for very light skin. Clothing covered much of the body, altering UV exposure. Indoor, living in agricultural societies affected how much sunlight people received. Skin tone evolution became a negotiation between nature and culture, a balancing act rather than a binary switch. Digestive evolution, new environments within us. Agriculture also changed our gut microbiome and our genes by introducing higher starch diets, new grains, domesticated meats, fermented foods, cooked tubers. Populations with high-starch diets developed more copies of the AMY1 gene, which produces amylase, the enzyme that breaks down starch. This wasn't about survival versus death. It was about efficiency, resilience, and subtle advantages over long generations. Evolution whispered. Culture shouted. Together they shaped us. Brain and behavior, small changes in the shadows. One of the most controversial, but increasingly studied, areas of post-agricultural evolution is how changes in environment and social structure may have influenced personality traits, stress responses, and cognitive patterns. While no single mutation dramatically reshaped the human brain after the cognitive revolution, small shifts appear in serotonin transporter genes, dopamine regulation, anxiety-related responses, introversion, extroversion frequencies, stress tolerance. Do these define individuals? No. Human behavior is far too complex. But at the population level, small evolutionary adjustments created subtle differences in how groups responded to environmental pressures. And once again, culture played the leading role. The pressures weren't predators, they were social norms, roles, expectations, rules, and structures. Human behavior became a conversation between biology and culture, each influencing the other without taking the lead. The grand pattern: slow, soft, subtle evolution. By the time we reach the late ancient world and the rise of classical civilizations, Egypt, Mesopotamia, China, Mesoamerica, biology had taken a back seat. Human bodies were stable. Human minds were fully modern. Human culture was accelerating faster than evolution could follow. This is the paradox. Evolution didn't stop. It decelerated and decentralized. Small changes continued. Regional differences emerged. Adaptations accumulated quietly, but none of it compared to the ocean of change happening culturally, socially, technologically, and symbolically. And this sets the stage for the next transformation, the one that would tilt the balance even further. Because while these subtle genetic shifts were unfolding, humanity was doing something evolution had never seen before. We began connecting civilizations into vast networks, and the flow of ideas soon became faster than the flow of genes. What happens to evolution when knowledge moves faster than biology ever could? That answer lies in the next chapter, because evolution was about to enter its quietest and most deceptive phase yet. By the time humans mastered agriculture, domestication, and long-term settlement, the rules of survival had already shifted dramatically. But what came next? A transformation that unfolded over thousands of years would push biological evolution even further into the background. That transformation was not a tool, not a mutation, not a new environment, but something far more powerful: connection. The rise of trade routes, alliances, shared mythologies, early writing, and cultural networks transformed humanity from isolated clusters into an interconnected species. And when information began moving faster than genes, evolution faced a competitor it simply could not match. In this chapter, we explore how the age of networks, stretching from roughly 10,000 to 3,000 years ago, silenced many of the old evolutionary forces forever. Because once humans began sharing not just resources, but ideas, biological evolution found itself overtaken by something faster, more adaptive, and infinitely more dynamic. The first great webs: trade routes and cultural highways. Trade is often imagined as the exchange of goods, but for ancient humans, it was something far deeper. Trade was the exchange of knowledge, rituals, stories, habits, and innovation. The moment two communities began interacting regularly, evolution gained a brand new environment: the environment of information. Obsidian from Anatolia traveled hundreds of miles into the Levant. Shell beads from the Mediterranean reached the Danube. Turquoise from the American Southwest was traded for macaw feathers from Mesoamerica. Spices and resins crossed the Indian Ocean long before recorded history. Each exchange carried more than objects. it carried solutions. If one community invented a better spear design, they didn't evolve stronger arms. They just adopted the design. If another discovered a medicinal plant, they didn't evolve immunity. They shared the cure. If one group perfected irrigation, others copied the system rather than waiting for natural selection to improve their kidneys. Evolution lost another domain of influence. Innovation outpaced mutation. For the first time in the history of life, culture evolved faster than genes could mutate. The time required for a beneficial mutation to spread widely is often thousands of years, but a cultural innovation, a tool, a technique, a theory, can spread across an entire region within a generation. Consider this contrast. A genetic mutation that improves hunting efficiency might take centuries to matter, but a new spear thrower, bow, or arrow design improves hunting immediately. A biological improvement to digestion might take millennia, but the invention of pottery, fermentation, or cooking techniques improves digestion instantly. A mutation that helps store warmth in cold climates could take hundreds of generations. But clothing and structured shelters solve the same problem overnight. Culture wasn't just replacing evolution, it was outcompeting it. For evolution, this was a losing race, and as the networks grew, the gap only increased. The social shield, cooperation at scale. Early societies protected individuals in ways nature never could. But as networks expanded, through alliances, trade, and early diplomacy, the social shield thickened even more. If a village suffered drought, its allies could provide food. If a community faced disease, others might offer herbs or knowledge. If one group lacked a certain resource, trade routes supplied it. Evolution relies on isolation. Networks create connection. Isolation sharpens selective pressures. Connection softens them. This is why evolution slowed further. Regional gene pools mingled. Diseases became shared rather than isolated. Innovations proliferated widely. Intermarriage expanded genetic diversity. Shared knowledge increased survival rates. Once communities interlinked, even minor hardships rarely wiped out entire populations, the key driver of strong selective pressure. The world of evolution became a web, not an island. Myth, memory, and meaning, the invisible architecture. The age of networks wasn't only about physical movement, it was about mental networks. Shared mythologies connected distant peoples into cultural families. Sun cults across Africa, flood myths across Mesopotamia, India, and the Mediterranean, serpent myths across the New World, sky gods across Eurasia, mother goddesses across agricultural regions. These shared stories weren't random. They were survival systems, embedding lessons about cooperation, morality, fertility, danger, seasons, and the cosmos. Stories became evolutionary tools, and unlike genes, stories could change instantly. A new myth could spread across thousands of people in a handful of years and influence behavior far more dramatically than a genetic trait. Once again, culture outpaced biology. Writing, the death blow to genetic evolution's tempo. Around 5,000 years ago, something emerged that changed the human species more profoundly than any mutation since the dawn of our kind. Writing. With writing, knowledge no longer depended on memory or oral transmission. It became durable, transportable, archivable, replicable. Writing allowed laws to stabilize societies, contracts to formalize trade, medical knowledge to accumulate, mathematics to flourish, agricultural techniques to spread, religions to grow, history to persist, administration to scale, ideas to survive beyond individuals. This was cultural immortality. Biology had nothing to compete with it. A mutation lives only through reproduction. A written idea can live forever, shared across continents, preserved through time, immune to death. With writing, culture didn't just outpace evolution, it transcended it. Empires. Evolution's softening becomes complete. The rise of empires. Egyptian, Sumerian, Babylonian, Harappan, Olmec, Chinese completed the transformation. Large organized states created, sophisticated food storage, irrigation systems, property rights, professional armies, labor specialization, bureaucratic support networks, advanced healthcare, sanitation systems, public works projects. These systems insulated individuals from environmental pressures more effectively than any previous innovation. Weak individuals survived. Sick individuals survived. Injured individuals survived. Incompetent individuals survived. Those with traits once lethal in the ancestral world now lived long enough to pass on their genes. Evolution did not eliminate these traits because culture protected them. This is why human diversity includes traits that natural selection would have erased long ago, because culture changed the rules. Evolution had become so soft, so diffuse, so slow, that it almost seemed to disappear. But it didn't disappear. It simply waited. Because while networks made humanity stronger, they also introduced a new kind of pressure, one evolution had never faced before. A pressure not from nature, but from other humans. The next chapter reveals this new force. Because once networks connected us, competition scaled, creating pressures evolution never anticipated. Up to this point in our journey, we've explored how nature once shaped the human body with unrelenting force, only to lose its power as culture, cooperation, agriculture, and networks emerged. But the rise of interconnected societies created a new kind of selective pressure, something evolution had never faced before. Competition, not against nature, but against other humans. This is the moment where a profound shift occurs. The old enemies, predators, starvation, exposure, fade. A new enemy takes their place. Ambition, rivalry, conflict, inequality, status, war. For the first time in our history, the primary challenge to human survival wasn't the environment, it was each other. How does evolution behave in a world where danger comes from the minds of other humans, not from claws or climate? How does biology adapt when threats are social, political, psychological, even ideological? To understand why our bodies remained stable while our societies grew vast and complex, we must enter this new landscape of human-driven pressures. The rise of inequality, a new selective landscape. In small hunter-gatherer bands, resources were shared. Hoarding was difficult. Status was fluid. Leadership was temporary. No one lived significantly better or worse than anyone else. But when agriculture created surplus, surplus created hierarchy. Some families controlled irrigation. Some managed the granaries. Some owned the land. Some directed labor. Some commanded armies. Some interpreted the gods. Some recorded laws. For the first time, humans existed on a vertical ladder of status, and your place on that ladder greatly influenced your survival and reproductive success. But here's the twist. These differences didn't create new evolutionary pressures toward physical strength or anatomical change. They shaped behavior instead. Why? Because you couldn't fight your way up the hierarchy with muscles alone. You needed persuasion, alliances, strategy, deception, memory, symbolic thinking, emotional intelligence, charisma, planning, social awareness. These traits weren't physical. They were cognitive and psychological. They were shaped not by genes alone, but by upbringing, culture, environment, and experience. Once again, culture, not biology, became the determining force. Warfare, evolution meets human complexity. As societies grew and resources multiplied, conflict scaled accordingly. Earlier hominins may have fought skirmishes, but organized warfare is uniquely human and uniquely cultural. It is not written into our anatomy. Consider what war selects for: teamwork, loyalty, planning, fear management, endurance, courage, leadership, coordination. But none of these require dramatic biological changes. They require socialization, training, and shared narratives. When an army marches into battle, its effectiveness does not come from evolved claws or thicker skulls. It comes from tactics passed down through generations, training programs, symbolic motivation, written commands, shared identity, technology. War wasn't an evolutionary pressure in the biological sense. It was a cultural arms race, an arena where ideas, not genes, determined survival. Evolution had no chance of keeping up. Selection shifts to behavior and mindset. In this new world, physical traits mattered far less than psychological ones. Think about which individuals thrived in early civilizations. Not the strongest, not the fastest, not the hardiest in pure physical terms, but those who could navigate social hierarchies, manage stress, negotiate disputes, organize labor, memorize rituals, follow complex rules, interpret symbols, leverage relationships, conform to cultural expectations. These traits created reproductive advantages, but crucially, they weren't genetically determined in any straightforward way. They were taught, modeled, reinforced, and transmitted through culture. Evolution couldn't encode these behaviors quickly or precisely. Culture did it instantly. This is why human behavior is so incredibly flexible, and why human bodies stayed so stable. Mercy, medicine, and morality, the final weakening of natural selection. Unlike other species, humans developed systems that protected the vulnerable, caring for the injured, feeding the elderly, defending children, providing for the disabled, healing the sick, distributing food in crises, establishing moral codes, enforcing laws against violence. This is unprecedented in the natural world. Animals may show compassion, but they do not build institutions of compassion. These systems did something evolution had never encountered. They allowed individuals with traits that would once have been fatal to survive and reproduce. Diseases that would have killed ancient hunter-gatherers were now treated. Weakness that once doomed a child was now supported by community. Mental health challenges were mitigated through social structures and storytelling. Physical frailty was often irrelevant in a world of tools and networks. Natural selection softened into something almost symbolic, a faint echo of its ancient power. Evolution was still happening, but the pressure was no longer life or death. It was preference, culture, and environment. The cognitive plateau, why the brain stopped growing. For millions of years, the human brain increased in size, demanding enormous energy and reshaping childbirth entirely. But around 100,000 years ago, brain growth stopped. Why? Because bigger wasn't better anymore. The brain had reached a level where language was possible, abstract thought was possible, planning was possible, symbolism was possible, imagination was possible, cooperation was possible. Any further increase would have cost more energy with no guaranteed benefit. Evolution reached a cognitive equilibrium, and everything after that point, every invention, civilization, religion, war, philosophy, tool, and empire, was built not by biological evolution, but by cognitive software, not anatomical hardware. Our brain became the stage, not the story. The social brain, an evolutionary endgame. Anthropologists sometimes speak of the social brain hypothesis, the theory that our brains evolved primarily to navigate complex social environments. Once humans mastered large-scale social living, evolution achieved its goal. The machinery was complete. The software would take over from here. And so, as societies expanded and interconnected, evolution ceded the future to law, myth, culture, innovation, cooperation, competition, memory, meaning. Human bodies remained stable because they no longer needed to change. Human minds remained flexible because culture needed to change. Evolution's job had ended. Culture's job had begun. But this story is far from finished. Because as societies grew even larger, forming empires, economies, religions, and global trade networks, a new form of evolution began to emerge. Not biological, not cultural, but something between the two. Sexual selection, not who survives, not who adapts, but who chooses and why. And that shift would create a new chapter in the story of human evolution. Because after survival was secured, desire became the next great evolutionary force. Until now, our journey journey has followed the massive forces that shaped humanity: catastrophe, bottlenecks, cognition, culture, society, agriculture, and networks. These forces explained why physical evolution slowed, why the human body stabilized while culture raced forward. But there is another kind of evolution, one that doesn't rely on the environment killing the unfit or rewarding the physically superior, a force that operates not through survival, but through preference. This force is sexual selection, the evolution driven not by nature, but by desire. This is one of the most misunderstood and most powerful chapters in the story of our species, because once humans no longer struggled simply to survive, a new question emerged. Who do we choose, and why? Those choices would shape the subtle edges of human behavior, appearance, personality, and even the rhythms of our cultures, not through dramatic anatomical transformations, but through the collective weight of countless intimate decisions: who to partner with, who to avoid, who to admire, who to trust. In this chapter, we explore how sexual selection continued shaping humanity long after natural selection softened, and how desire became a quiet evolutionary engine in the background of history. When survival no longer decided everything, when early humans lived under intense natural pressures, sexual selection had limited room to operate. If a trait threatened survival, too showy, too fragile, too risky, it was quickly removed from the gene pool. But once culture, cooperation, and technology began buffering us from danger, survival became easier, and something remarkable happened. Evolution stopped eliminating traits and started negotiating them. Personality, attractiveness, temperament, even subtle physiological differences began to matter, not because they affected survival, but because they influenced choice. This is the moment when human biology began to follow human psychology. Our species entered a world where desirability shaped destiny. The emergence of aesthetic preferences. Nearly every culture on Earth, ancient or modern, has developed ideas about beauty, symmetry, charm, strength, intelligence, creativity, humor, or charisma. These preferences are not random. They create evolutionary currents. Consider this. Individuals judged more attractive tended to have more reproductive opportunities. Personality traits like kindness, patience, and cooperation were often favored. Leadership qualities increased status, and status influenced mating. Creativity, art, music, storytelling became signals of intelligence and genetic fitness. Humor and social fluency helped individuals navigate complex social groups. None of these traits required new biological adaptations to survive, but they did influence which traits passed forward. Sexual selection didn't reshape the human body dramatically. It reshaped the mind, the face, the behavior, the voice, the social instincts, subtly, incrementally, across tens of thousands of years, the social marketplace of ancient societies. As societies grew, so did their social hierarchies, and within those hierarchies, sexual selection intensified. High-status individuals often had more reproductive opportunities. Wealth, influence, and leadership became attractive qualities, not because they were genetic, but because they increased survival for children. This created new evolutionary pathways. Ambition could translate into larger families. Social intelligence provided advantages. Cooperation became a desirable trait. Conflict resolution skills increased reproductive success. Artistic or ritual roles offered prestige. Knowledge keepers and storytellers gained admiration and influence. In other words, evolution began rewarding those who navigated society well. Not the strongest, not the fastest, not the fiercest, but those who fit the cultural ecosystem. This explains one of the greatest mysteries of human evolution. Why do human beings have such complex emotional and social lives? Why do we experience love, jealousy, loyalty, shame, admiration, fear of rejection, and desire for belonging? Because these emotions were shaped in a world where mating choices, not survival challenges, determined reproductive success. Culture didn't just protect humans from death, it guided them toward partners who fit the social world. From ornament to identity, the rise of cultural signals. Human attraction, unlike animal attraction, became intertwined with culture. What we find appealing, beauty standards, values, roles, behaviors, began to reflect cultural meaning. Clothing styles, hairstyles, body markings, ritual dances, ornaments, symbols of status, language fluency, storytelling ability, confidence, generosity, creativity. These became signals, cultural traits that indicated social value or capability. Evolution couldn't encode these signals genetically. Culture encoded them symbolically. This is why sexual selection became a cultural force first and a biological force second. We weren't selecting for bones and muscles. We were selecting for identity. This explains why human variation is so subtle, why we don't have dramatic evolutionary changes like peacock feathers or elk antlers. Human attractiveness is defined mostly by behavior and culture. Our bodies remained stable because attraction moved into the realm of psychology and symbolism, the hidden evolution of temperament. While sexual selection didn't produce major anatomical changes, it likely influenced temperament across centuries. Traits such as empathy, emotional stability, willingness to cooperate, trustworthiness, long-term planning, parenting tendencies, social adaptability, creativity, humor, ambition, curiosity. These traits affect social success, relationship stability, and mating patterns. Evolution didn't need to redesign the human body. It needed only to adjust the subtle architecture of human behavior, and it did so quietly, nudging tendencies in populations depending on cultural pressures. For example, peaceful agrarian societies favored individuals who cooperated. Warrior cultures valued courage, loyalty, and resilience. Highly stratified empires rewarded obedience, patience, and social navigation. Nomadic societies valued adaptability and independence. Artistic or ritualistic cultures rewarded creativity and expressive ability. These weren't genetic absolutes, but trends shaped by generations of preference. Evolution was no longer about survival. It was about compatibility. Love as an evolutionary innovation. One of the most profound consequences of sexual selection in humans is the evolution of pair bonding, the emotional and social glue that binds partners together. Anthropologists often argue that love isn't an emotion, it's a strategy, a deeply human strategy for shared parenting, mutual support, emotional stability, resource cooperation, long-term planning, social reputation, intergroup alliances. But love also shaped evolution by influencing who stayed together, who raised children successfully, and whose values carried forward. Evolution did not design love for beauty. It designed love for survival in a world where culture, not biology, decided the future. This is why love can override physical attractiveness, why loyalty can override status, why compatibility can override instinct. Human evolution became a dialogue between emotion and culture, and this brings us to a crucial point. By the time human societies entered the classical world, evolution had become so subtle and so entangled with culture that biological change was nearly invisible. But invisible does not mean irrelevant, because as history marched forward and civilizations expanded across continents, humanity stumbled into yet another transformation, one that would weaken natural selection to its softest point in all of human history. A transformation born not from desire, but from abundance. Because the rise of civilization would bring an entirely new evolutionary dynamic, one where excess, not scarcity, defined the human world. By the time agriculture matured into kingdoms, and kingdoms grew into empires, humanity experienced something unprecedented in our 4 million-year story. Stability, predictability, surplus, comfort. For the first time, people lived in societies where life wasn't a constant battle against starvation, predators, or environmental chaos. Instead, humans found themselves inside organized systems, structured, layered, stable, capable of feeding millions, defending borders, redistributing wealth, and storing knowledge across generations. This shift, subtle at first, eventually reached a tipping point, and when it did, it created a force powerful enough to silence the last remnants of intense natural selection. This force was abundance, and abundance changed everything. Evolution once sculpted us through hardship. Now it struggled to operate in a world of comfort. To understand why human evolution slowed even further and why our bodies remained almost unchanged while our cultures, technologies, and civilizations transformed beyond recognition, we must venture into the heart of ancient abundance, because this is when the human world truly diverged from the natural world. This is when biology and culture officially parted ways. The first cities of plenty. Imagine standing in the ancient city of Uruk around 5,000 years ago. Towering ziggurats rise above bustling streets. Markets overflow with grain, dates, fish, textiles, pottery, and tools. Bureaucrats track inventories on clay tablets. Priests oversee rituals that bind thousands of people into a shared belief system. This is a world where famine is managed, conflict is organized, land is irrigated, labor is specialized, knowledge is archived, medicine is practiced, criminals are judged, children grow up surrounded by social scaffolding. Contrast this with our early ancestors, constantly exposed to predators, storms, hunger, and unpredictable environments. In this new world, death was no longer the primary sculptor of humanity. Structure was. Systems replaced natural pressures. Institutions replaced random chance. Social expectations replaced biological instincts. People survived not because their genes made them robust, but because their society was robust. This was the beginning of a new evolutionary condition, where the environment became human-made. Abundance softens the harsh edges of selection. In nature, food scarcity is one of the greatest drivers of evolution. Scarcity filters populations, punishes the unfit, rewards resilient traits, intensifies selective pressure. But in civilizations with granaries, surplus, irrigation, trade routes, and taxation, scarcity became manageable. Humans no longer evolved based on who could endure hunger. They survived based on social status, inherited wealth, community support, redistribution systems, long-term planning, economic organization. This shift fundamentally changed the evolutionary landscape. In the natural world, a poor year could wipe out a generation. In a civilization, a poor year could be offset with stored grain, imported food, organized labor, shared resources, political intervention. Evolution lost yet another opportunity to sculpt us. Technology divorces us from natural consequences. As civilizations advanced, technology began providing solutions. Evolution once handled alone. Consider the following: food too hard to digest, grind it, cook it, ferment it. Climate too harsh, build better homes. Seasonal clothing, dangerous animals, fences, spears, walls, traps. Illness, herbal medicine, early surgery, sanitation, hard labor, domestic animals, irrigation systems, metal tools, long distances, boats, wheels, roads. Technology didn't just help humans survive, it eliminated survival pressures. Why evolve stronger jaws when you can grind grain into flour? Why evolve better heat tolerance when you can invent shade structures? Why evolve faster legs when you can ride horses or build chariots? Every technological innovation made biological adaptation less necessary. And as this happened, human anatomy remained stable. Our bodies were no longer competing with nature. They were cooperating with culture. The rise of social safety nets in ancient civilizations. We often imagine welfare and social safety nets as modern concepts. But early civilizations had their own versions: grain rations, temple food distributions, community care for the elderly, arranged marriages for unsupported women, apprenticeship systems, collective farming, guilds and trade networks. soldier stipends, medical specialists, orphan support programs. These systems protected individuals who, in earlier ages, would not have survived. The fragile, the sick, the injured, the mentally unstable, the physically impaired, the socially isolated. They were no longer filtered out of the gene pool. This represents one of the greatest reductions of natural selection in human history, not because humans became weaker, but because society became stronger. Cultural evolution reaches warp speed. As populations grew dense and communication spread, culture began evolving faster than ever before. New religions, new mythologies, new technologies, new philosophies, new political systems, new languages, new forms of art and expression. Civilizations exchanged ideas through trade, conquest, migration, marriage alliances, scribal traditions, schools, traveling artisans, merchant guilds. The rate of cultural innovation outpaced the rate of biological evolution by orders of magnitude. Evolution became slow. Culture became explosive. This widening gap created a strange new world, one where human bodies remained ancient, but human societies became modern. It's as though anatomy froze in place while the mind sprinted ahead. Disease becomes the last strong natural pressure. Despite abundance, one selective force remained powerful: infectious disease. In dense cities like Babylon, Mohenjo-Daro, Athens, Rome, Teotihuacan, Chang'an, diseases spread faster than ever before. Plagues killed millions. Outbreaks reshaped populations. Immunities emerged regionally. Mutations rose and fell. But even here, culture intervened. Sanitation, quarantine, herbal medicine, hot baths, dietary laws, water systems, urban planning. Cities didn't allow diseases to sculpt bodies dramatically. They responded to diseases as cultural problems, not evolutionary ones. Evolution had one last domain, but civilization kept shrinking it. Wealth, power, and evolution in the ancient world status became one of the most significant determinants of survival and reproduction in ancient civilizations. But status wasn't genetic, it was cultural, and because it was cultural, it did not create consistent evolutionary outcomes. A person could rise through military achievement, religious authority, craftsmanship, literacy, artistry, commerce, marriage, politics. None of these were biological. All were cultural. Evolution could not create consistent selection patterns because status was fluid, contextual, and socially determined. Biology had lost the ability to direct the human future. The meaning of abundance in the human story. Abundance did not make humans lazy. It made humans powerful. It freed us from the strict demands of natural selection. It allowed ideas to flourish. It protected the vulnerable. It rewarded intelligence, cooperation, and creativity. It created space for innovation and experimentation. It dramatically expanded human lifespans. It allowed cultures to develop deep identities and vast institutions. But abundance also ensured one thing: human evolution slowed to its quietest pace in history. Not because we were done evolving, but because culture became the dominant force in our existence. The next step will take us into the Middle Ages and the early modern period, when disease, empire, and global contact reshaped humanity once again. Because while evolution remained quiet, history was about to roar. What happened next would change the genetic landscape of humanity in ways no ancient civilization could have predicted. As the ancient world matured into the Middle Ages, and the Middle Ages transformed into the early modern era, something unprecedented began unfolding across continents. Civilizations collided, ideas collided, languages collided, cultures collided, technologies collided, belief systems collided, populations collided. And with each collision, humanity entered a turbulent evolutionary environment unlike anything before it. An environment where biology, culture, disease, exploration, and empire intertwined in unpredictable ways. This era did not reverse the slowing of biological evolution. It refined it, redirected it, complicated it, accelerated it in small, sharp bursts, and nearly stopped it in others. To understand why the human body changed so little over the last 1,000 years, yet human populations reshaped themselves so dramatically, we must enter the storm of history itself. Because in this age, the pressures shaping humanity weren't natural or anatomical, they were geopolitical, epidemiological, and cultural, and they came with consequences evolution had never faced before. The medieval paradox: hard times, soft evolution. It is tempting to imagine the Middle Ages as brutal and unforgiving, and in many ways they were. But brutality alone does not guarantee strong evolutionary pressure. In fact, the opposite is often true. Why? Because hardship must consistently target specific traits to shape a species. But medieval hardship was chaotic, uneven, and socially mediated. Food shortages didn't target genetic weakness. They targeted the poor. War didn't target physical inferiority. It targeted whoever lived near the front. Famine didn't target maladaptation. It targeted misfortune. Oppression didn't target biological flaws. It targeted social categories. In earlier eras, hardship filtered the physically unfit. In the Middle Ages, hardship filtered the socially unprotected. Evolution's hand grew weaker, not stronger. The Black Death, evolution's sharpest whisper. Yet among the many forces of this era, one stands apart: the plague. When the Black Death erupted in the mid-14th century, it wiped out 30% to 50% of the population across Europe, the Middle East, and North Africa. It was one of the most devastating biological events in recorded history. Plague was indiscriminate in many ways, but not entirely. Those with certain immune system variations, mutations in genes related to inflammation, pathogen recognition, and cellular defenses survived at slightly higher rates. This subtle difference had massive long-term effects. It reshaped immune gene frequencies across Europe. It influenced susceptibility to certain autoimmune disorders today. It created regional differences in pathogen resistance. It left detectable signatures in modern genomes. But here is the crucial point. Even this catastrophic event, one of the deadliest in human history, did not significantly reshape human anatomy or drastically alter our biological profile. Why? Because plague didn't reward new physical traits. It rewarded existing immune system variation already present due to millions of years of evolution. The Black Death whispered into our DNA. It did not sculpt us anew. The age of exploration, when the planet became a genetic mixing chamber. The next epoch in our story, the Age of Exploration, transformed evolution not through selective pressure, but through migration and mixing. For tens of thousands of years, humans lived in relatively separate genetic clusters. But beginning in the 15th century, ships crossed oceans, and continents that had been isolated reunited. This led to massive population mixing, genetic blending, exchange of immunities, movement of traits across regions, intercontinental marriages, merging of gene pools. Examples include African, European, and indigenous American ancestry blending across the Americas, Mediterranean, Middle Eastern, and South Asian populations mixing through trade and empire, Southeast Asia becoming a genetic crossroads between China, India, Polynesia, and Indonesia. This wasn't natural selection, it was gene flow, the movement of traits through social and cultural interaction. When populations mix, evolution changes course. It becomes more diverse and less predictable. But crucially, mixing did not produce radical new traits or subspecies. It simply redistributed the existing genetic palette created long before. Columbian exchange. When diseases became evolutionary hurricanes. When Europeans, Africans, and Native Americans encountered one another, pathogens moved with them, and the effects were catastrophic. In the Americas, where smallpox, measles, and influenza arrived for the first time, mortality rates reached up to 90% in some regions. This wasn't selection, it was annihilation. But even here, evolution did not create dramatic new traits. Instead, surviving populations rebounded through cultural adaptation, immune system diversity increased through mixing, medical practices slowly improved. Vulnerability decreased as population stabilized. Biology responded modestly. Culture responded dramatically. Once again, evolution remained subtle. Empire, trade, and the globalizing human experience. As the world interconnected through Silk Road networks, Indian Ocean trading routes, Islamic Golden Age scholarship, the spread of Christianity and Islam, maritime empires, Portuguese, Spanish, Dutch, British, colonial systems, industrial trade, migration for labor and opportunity, human societies became complex networks of interdependence. In this world, intelligence mattered more than brute strength, literacy created status, bureaucracy determined opportunity, wealth influenced survival, social mobility altered family size, cultural identity shaped community support. These pressures shaped who married whom, who reproduced, and who thrived, but not through biological fitness. They operated through education, class, language, belief, economics, politics, law, opportunity traits, shaped by culture, not genes. Evolution had lost almost all its traditional levers. The industrial barrier, when technology became the ultimate shield. By the time the world entered the Industrial Revolution, the last remaining natural filters collapsed. Medicine advanced, child mortality dropped, sanitation improved, food supply stabilized, global trade eliminated local scarcity, machines replaced physical labor, transportation connected distant communities, cities expanded, science began understanding disease, governments enforced safety. Every one of these innovations weakened natural selection even further. Where ancient humans faced lions, storms, and starvation, modern humans faced challenges solved by technology, institutions, infrastructure, planning, specialization. Evolution was nearly silent, but it wasn't dead, because as we step toward the modern era, something extraordinary begins, a new form of evolution, one unlike anything in the natural world. Self-directed evolution, technological evolution, genetic engineering, AI-mediated selection, cultural self-modification. Humanity was preparing to transcend the limits of biology entirely. And that is where our journey leads next. Because the next phase of evolution will not come from nature, but from us. For millions of years, life on Earth evolved blindly, shaped by climate, predators, scarcity, and chance. Every species that ever lived was sculpted by forces outside itself. Nature decided who thrived. Nature decided who vanished. But in the last few centuries, humanity stepped into a new and unprecedented chapter, one that shattered this ancient rule, rewriting the very meaning of evolution. For the first time in the history of life, a species gained the power to shape itself, not through instinct, not through biological struggle, but through knowledge. The moment this transformation began is difficult to pinpoint. Some trace it to the invention of agriculture, others to the rise of writing, still others to the first cities or the birth of medicine. But in truth, the real turning point came when humans stopped reacting to the environment and started engineering it. Welcome to the dawn of self-directed evolution, the era when culture, science, and technology became the dominant forces shaping humanity's future. This chapter explores how we reached that threshold, what it means, and why the final slowdown of natural selection wasn't the end of our evolutionary story, but the beginning of a new kind of evolution altogether. The birth of medicine, the first human intervention in evolution. For most of human history, sickness was destiny. A cut could kill, a fever could end a bloodline, a broken bone was an evolutionary verdict. But as civilizations matured, something revolutionary emerged: healing. At first, this healing was symbolic: rituals, herbs, chants, and offerings. But even rudimentary medicine mattered. It preserved individuals who would otherwise have died. It allowed cultural knowledge to accumulate. It gave communities stability. Yet the real evolutionary shift began with surgical tools, herbal pharmacology, sanitation, midwifery, dental practices, anatomical studies, quarantine, early hospitals. These early interventions weakened natural selection further. Traits that would once have been fatal, poor eyesight, weak immune responses, fragile bones, no longer eliminated individuals from the population. Evolution slowed, but something else accelerated: human agency. We began to shape survival deliberately. Science emerges. Evolution meets understanding. The scientific revolution of the 16th and 17th centuries changed everything. For the first time in human history, disease was studied, not feared. The body was analyzed, not mystified. Nature was measured, not worshipped. Medicine was tested, not assumed. Knowledge grew predictably, not randomly. This predictability, the ability to understand cause and effect, allowed humans to intervene in evolution more effectively than ever before. Vaccines, antibiotics, sterilization techniques, nutrition science, public health measures, epidemiology, surgery. Every discovery further weakened natural selection, replacing it with technological selection. Evolution's sculptor became human intention, industrialization, and the disappearance of ancient pressures. If the scientific revolution gave humans knowledge, the industrial revolution gave them power. Machines replaced muscle, factories replaced fields, transport networks replaced isolation, mass production replaced scarcity, public works replaced vulnerability. For the first time in human existence, most people no longer performed physically dangerous labor. Predation became non-existent. Famine diminished in many regions. Disease became treatable. Warfare changed form, favoring strategy over brute strength. Technology ensured survival regardless of biological fitness. Evolution's ancient pressures evaporated almost entirely. Traits that once determined life and death, speed, strength, stamina, lost their evolutionary relevance. Meanwhile, new pressures emerged: knowledge, education, creativity, social fluency, opportunity. But these were cultural pressures, not biological ones. They shaped lives, but not genes. Evolution had entered its softest era yet: globalization, the genetic reunification of humanity. When the world became interconnected through modern travel, something profound happened. Population mixing accelerated to levels unseen since the beginning of our species. This had two major effects. 1. Genetic diversity increased globally. Previously isolated populations blended, reversing some of the genetic narrowing caused by the ancient Toba bottleneck. 2. Selective pressures became homogenized. Different environments once produced different adaptations. Now, humans everywhere shared similar diets, similar technologies, similar medicine, similar tools, similar lifestyles, similar risks, similar protections. Evolution's regional pressures weakened. Humanity became biologically unified again. This was not the end of evolution. Far from it. It was the end of localized, environment-driven evolution. A new kind of evolution was beginning, one that came from human psychology, human technology, and eventually, human engineering, the silent evolution of intelligence and behavior. As society became more complex, new pressures formed, not in nature, but in human-created systems: education, social mobility, cognitive labor, emotional intelligence, communication, digital interaction, economic participation. These pressures influenced who succeeded, who reproduced, and who shaped society. But they didn't create genetic changes directly. They influenced cultural patterns. Evolution could no longer sculpt intelligence directly, because intelligence was becoming increasingly tied to environment, nutrition, education, childhood stability, cultural stimulation, technology access. Biology provided the potential. Culture decided the outcome. Evolution and culture had merged into something new, something neither could accomplish alone. The rise of modern medicine. Natural selection loses its last domain by the 20th century. Humanity achieved something evolution could never have anticipated. We overpowered disease through antibiotics, vaccines, antivirals, diagnostic imaging, transplants, genetic screening, neonatal care, chemotherapy, global health systems. Modern medicine ensured that individuals with traits once fatal not only survived, but lived long, meaningful lives and passed on their genes. This was the final collapse of classical natural selection. For millions of years, life had been shaped by the survival of the fittest. Now, life was shaped by the survival of everyone. Evolution wasn't gone. It was simply no longer in charge. The technology horizon. A new type of evolution emerges. As the 21st century unfolds, humanity stands at the dawn of a new evolutionary phase, one where the drivers are no longer genetic mutations or environmental pressures, but technological innovations. Gene editing, CRISPR, synthetic biology, embryo screening, longevity research, artificial intelligence, biomechanical augmentation, neural interfaces, data-driven lifestyles. For the first time, evolution is entering a phase where biology is no longer destiny, where humans can repair genes, modify embryos, extend life, enhance abilities, merge with machines, rewrite biological limitations. This isn't evolution ending, it's evolution accelerating, powered by intention rather than adaptation. We are not the passengers of evolution anymore. We are becoming its architects. But this new power raises the ultimate question. If humans now choose their evolutionary path, what kind of species will we choose to become? The next chapter takes us into the future, a place where evolution's role is uncertain, and technology has begun to replace nature itself. Because humanity's next transformation will not be written in our DNA, but in our decisions. We now step into the most uncertain, exhilarating, and unnerving chapter of the human story. Up to this point, evolution shaped us through catastrophe, scarcity, culture, connection, and medicine. Slowly, almost imperceptibly, the balance shifted from genes to ideas, from biology to technology, from natural selection to human intention. But today, right now, we are crossing a threshold no species has ever crossed. For the first time in Earth's history, a creature understands evolution well enough to intervene in it, to redirect it, to accelerate it, to rewrite it. The future of human evolution is no longer a story carved into our bones by distant ancestors. It is a story we are actively composing, word by word, choice by choice, technology by technology. In this chapter, we explore the horizon of this transformation, the age when humanity stops being shaped by evolution and begins shaping evolution itself. The return of a question that once shaped us. What does it mean to be human? Human evolution began with a simple principle: survive long enough to reproduce. But in the coming centuries, survival will no longer be the challenge. The challenge will be identity. Who are we when our biology is no longer fixed? What is a human when the boundaries of the body dissolve? What is evolution when natural selection gives way to intentional design? These questions will define the next era, because humanity stands at the intersection of multiple technological revolutions, all of which affect our evolutionary future: gene editing, artificial intelligence, synthetic biology, nanotechnology, cybernetic augmentation, life extension, cognitive enhancement, digital integration, space colonization. Each of these forces represents a new evolutionary pressure, one not imposed by nature, but by human choice. CRISPR and the birth of genetic editing. In 2012, CRISPR-Cas9, an elegant bacterial immune system, became a tool for rewriting DNA with unprecedented precision. This technology gave humanity a power once reserved for nature alone: the power to change the genetic code. No longer must we wait for random mutations. No longer must we accept inherited diseases as destiny. No longer must evolution be blind. Through gene editing, humans may soon eliminate hereditary illnesses, enhance immune systems, modify metabolism, increase longevity, alter physical traits, boost cognitive potential, engineer resistance to radiation for space travel, design embryos with specific attributes. This is not hypothetical. It is happening now in small, cautious steps. Evolution is no longer a force acting upon humans. It is becoming a tool used by humans. But this raises a profound philosophical tension. Just because we can change our DNA, should we? Artificial intelligence, the new evolutionary mirror. While gene editing reshapes the biological side of humanity, artificial intelligence reshapes the cognitive and cultural side. AI does not evolve slowly or biologically. It evolves rapidly, algorithmically, iteratively, without the limits of metabolism or mortality. In a sense, AI is the first non-biological entity to join the evolutionary stage, a new intelligence that forces humanity to reflect on its own nature. Some researchers argue that AI will become humanity's external brain, allowing us to augment memory, expand reasoning, accelerate learning, outsource cognitive labor, mirror our own emotions, detect patterns our minds cannot perceive. But there is a deeper, more evolutionary question. If intelligence once drove cultural evolution, what happens when intelligence is no longer uniquely human? Does evolution shift again? From biological genes to digital minds? Does humanity merge with these systems? Do we become hybrid creatures, shaped not by nature but by neural interfaces and data streams? Evolution may not disappear. It may migrate from DNA to information, cyborgs, and the integration of machine and body. We often picture cyborgs as fictional beings, but the reality is already here. Artificial limbs controlled by neural signals, cochlear implants restoring hearing, retinal implants enhancing vision, deep brain stimulators treating neurological disorders, exoskeletons augmenting strength, brain-computer interfaces bridging thought and technology. These technologies blur the line between human and machine. In the future, enhancements may expand far beyond medicine. Augmented senses, digital memory implants, increased physical strength, enhanced resilience, implanted translation systems, magnetic field perception, infrared or ultraviolet vision, direct AI-assisted cognition. If natural selection once favored sharper senses and stronger bodies, technology will soon provide these enhancements without evolution. Evolution becomes modular, optional, customizable. The body becomes an editable platform. Life extension, redesigning the human timeline. For millions of years, human beings lived short, fragile lives. But in the last century, lifespans nearly doubled. And this is only the beginning. Research into aging suggests that lifespan may be extendable, programmable, reversible through telomerase manipulation, senescent cell removal, stem cell regeneration, mitochondrial repair, caloric restriction, mimetics, genetic modifications, nanomedicine. If humans live not 80 years but 150 or 300 or indefinitely, evolution shifts again. Longer lives mean slower generational turnover, increased learning, reduced mutation spread, altered family structures, deeper cultural continuity, new psychological landscapes. Longevity isn't just a medical challenge, it is an evolutionary transformation. Cultural selection becomes the dominant force. As technology advances, a new form of selection emerges. Not natural, not sexual, but cultural technical selection. Traits that are rewarded in a technologically mediated world will shape the future. Adaptability, cognitive flexibility, emotional intelligence, digital fluency, creativity, cross-cultural cooperation, innovation, strategic thinking. These traits aren't biological, they are behavioral, and they are taught. Human evolution shifts yet again from biological inheritance to cultural inheritance. Our fitness now depends on how well we navigate technological and social ecosystems, not ecological ones. Evolution becomes psychological, not anatomical. The final break. Evolution loses its authority. Throughout this entire story, evolution has been relentless, creative, corrective, unforgiving, patient. But as humans gain control over genetics, culture, and technology, evolution's authority weakens. We no longer wait for mutations. We no longer rely on selection. We no longer depend on survival pressures. Humanity is no longer a product of evolution. Humanity is becoming an agent of evolution. And this leads us to the most important question of all. If the future of our species depends entirely on our choices, what choices will define us? The answer lies in the next chapter, where we confront the future of humanity not as a biological species, but as a self-engineering civilization. Because the next stage of evolution won't shape us accidentally. We will shape it deliberately. For the first time since life began on Earth, more than 3.5 billion years ago, evolution is no longer a blind sculptor. Instead, it has a partner, an editor, a critic, and increasingly a replacement. That replacement is us. As humanity crosses into an age of self-directed evolution, the greatest challenge we face is no longer biological survival. It is design, the conscious shaping of what it means to be human. The blueprint of our species is shifting from a fixed genetic inheritance to a flexible, editable template. This chapter explores how that blueprint is changing, how we moved from inherited traits to engineered ones, from natural adaptation to strategic redesign, from evolution to deliberate crafting. And at the center of this transformation lies a question that evolution never had to answer. If humans can be anything, what should humans be? The three pillars of self-driven evolution. Humanity's entry into the age of design is being built on three powerful pillars. 1. Biological engineering. We can now alter DNA itself, editing mutations, enhancing traits, and eliminating hereditary diseases. CRISPR is only the beginning. 2. Technological augmentation. From neural implants to external exoskeletons, humans can radically extend their capabilities using machines. 3. Cultural acceleration. Ideas, norms, and values evolve faster than biology. Culture shapes identity, behavior, and social evolution at a pace no genetic mutation can match. Together, these pillars create a new evolutionary environment, one where biology, technology, and culture merge into a single system. This is not evolution in the old sense. It is a hybrid evolution, part genetic, part artificial, part symbolic. In this world, survival pressures shift from nature to negotiation, from scarcity to structure, from physical landscapes to psychological and digital ones. The rise of the engineered human. Imagine a child born 50 years from now. From conception, their genes are screened for potential issues. Hereditary diseases are edited out. Metabolic weaknesses corrected. Genetic predispositions for mental health issues softened. Natural resistance to pathogens strengthened. Muscle and bone density optimized for a sedentary environment. Cognitive potential enhanced for learning in a digital world. This child is not unnatural. This child is the next stage of natural, a human shaped by human understanding. Just as we once bred crops for resilience and animals for utility, we now stand on the threshold of guiding our own developmental pathways. But this guidance is not uniform. It will vary by culture, ideology, economics, and values. And those differences will create new evolutionary currents, not biological ones, but cultural and technological lineages. Humanity may not split into biological subspecies, but into cultural, technical species. The end of universal human anatomy? For hundreds of thousands of years, the human body remained mostly unchanged. But that stability was made for a world of walking, lifting, running, enduring. The world of the future will demand different kinds of bodies. We may see humans optimizing for environments with artificial climates, digital immersion, extreme longevity, space travel and low gravity, extended cognitive workloads, emotional resilience, disease-free biology, high-tech interfacing. Some enhancements will be internal, genetic or biochemical. Others will be external, prosthetics, wearable tech, neural links. Natural selection designed us for Earth, but we're designing ourselves for everywhere else. As humans begin to colonize the Moon, Mars, and beyond, new pressures will emerge. Radiation, low gravity, isolation, artificial food systems, confined habitats. Do we evolve naturally for these environments, or do we engineer ourselves for them? The future likely involves both. The psychological shift, identity in a plastic world. If biology becomes malleable, identity becomes fluid. In a world where humans can edit appearance, alter cognitive tendencies, change hormonal balances, augment perception, extend lifespan, integrate with AI, merge with machines, the very concept of a normal human dissolves. This raises profound evolutionary questions. If identity can be modified, what anchors individuality? If abilities can be chosen, what becomes of natural variation? If all disadvantage is removable, what happens to diversity? If evolution is customizable, what becomes of nature? These questions are philosophical, but they are also evolutionary, because evolution is not just about bodies. It is about behavior, reproduction, culture, and meaning. The human mind is entering a world evolution did not prepare it for. The reset of sexual selection. For millions of years, mate choice shaped subtle aspects of human temperament and appearance. But in a world of engineered bodies and augmented intelligence, sexual selection changes entirely. People may choose partners based on shared values, shared enhancements, compatible augmentations, engineered traits, life extension strategies, cognitive alignment, biological health profiles. Romance does not disappear, but its evolutionary significance changes. We begin choosing based on the future we want to build, not the traits we inherited from the past. This means evolution becomes intentional at the most personal level. Cultural divergence. Humanity splits by choice, not geography. In the past, evolution created diversity through isolation. But in the modern world, isolation is no longer geographic. It is cultural. Different cultures may choose different enhancements. Some will value longevity, some will value creativity, some will value resilience, some will value intelligence, some will restrict genetic modification, some will embrace radical transformation, some will merge with AI fully, others will preserve a traditional human identity. This is how humanity diverges, not through biology, but through cultural ideology. The future human species may not be Homo sapiens and something else. It may be multiple versions of Homo sapiens, each shaped by different philosophies of what a human should be. Evolution becomes a matter of worldview, the return of an ancient pattern, the illusion of control. Despite all these advances, we must acknowledge a deeper truth. Even self-directed evolution can never be fully controlled. Why? Because culture changes unpredictably. Technologies evolve beyond human understanding. Environments shift. Global crises reshape priorities. New diseases emerge. AI introduces novel pressures. Human psychology remains complex. Unintended consequences accumulate. Evolution is not ending. It is becoming harder to predict. The more we intervene, the more variables we introduce. The more powerful our tools, the more delicate the system becomes. We are stepping into a future where evolution is guided, but not mastered, influenced, but not commanded. Humanity is beginning to rewrite its own blueprint, but we are also entering the greatest experiment in biological history, the question at the threshold. As we look toward this future, engineered, augmented, hybrid, interconnected, we are forced back to the oldest human question of all. What should we become? Because evolution will no longer answer that for us. Nature will no longer decide. Chance mutations will no longer guide our destiny. We will decide. And that brings us to the next chapter of this story, the era when humanity must confront its own power, its limits, its responsibilities, and its potential. because the true challenge of self-evolution is not technological, it is ethical. And the next stage of our journey asks whether we are ready to guide evolution without destroying the very essence of being human. We have arrived at the edge of a precipice, a moment no species has ever faced, a moment when knowledge outruns instinct and power outpaces wisdom. Humanity's ability to modify its own evolution is real, accelerating, and irreversible. But the question that looms now is not, what can we do? It is, what should we do? This is the chapter where technology collides with morality, where biology meets philosophy, and where our power to transform ourselves becomes more dangerous than any natural threat we have ever faced. Throughout most of Earth's history, evolution was guided by blind forces. There were no ethical questions, no moral dilemmas, no decisions. There was only survival. But the moment humans gained the ability to choose, to intervene, to alter, to design, the world became a different kind of battlefield. A battlefield where the stakes are nothing less than the future of our species. The power to change everything, and the wisdom to change nothing. We are entering an era where humans will be able to design physical traits, regulate cognitive tendencies, enhance emotional resilience, prevent almost all hereditary disease, extend lifespan beyond biological limits, merge human cognition with artificial intelligence, optimize bodies for space environments, eliminate aging as we know it, tailor psychological traits to match societal ideals. But every one of these breakthroughs carries a hidden question. Who decides what is an improvement? Who defines healthy, optimized, normal, intelligent, desirable, safe, ethical, human? For the first time in our history, evolution is not just biological, it is political, philosophical, cultural, and deeply personal. The stakes could not be higher. The danger of a single vision for humanity. Throughout history, attempts to force a single vision of what a better human should be have led to oppression, violence, discrimination, eugenics, genocide, enforced homogeneity. The danger today is amplified by technology. If humanity ever agrees, intentionally or accidentally, on a narrow definition of what a superior human looks like, the consequences would be catastrophic. Loss of diversity, loss of creativity, cultural and genetic homogenization, psychological instability, vulnerability to global threats, ethical atrocities masked as progress. Diversity, biological, cultural, psychological, is the reason humans survived every catastrophe from Toba to the Black Plague. Uniformity has always been extinction's favorite strategy. Evolution thrives on variation. Technology, if misused, could erase it. The new inequality, access to enhancement. As self-directed evolution becomes possible, another threat emerges. A new axis of inequality unlike anything before, the enhancement divide. Imagine a world where some individuals can afford genetic upgrades, cognitive boosts, longer lives, immunity to disease, engineered vitality, enhanced memory and learning, AI-augmented perception, while others cannot. This is not the inequality of wealth. This is the inequality of biology, a divide not between rich and poor, but between enhanced and unenhanced, between those who are biologically amplified and those who remain as nature made them. Such a divide could fracture humanity more deeply than any ethnic, cultural, or national boundary ever has. We must ask now, before the technology becomes mainstream, who will control human evolution? Who will benefit? Who will be left behind? AI. As evolution's new gatekeeper, artificial intelligence introduces another profound ethical paradox. AI may soon become responsible for optimizing gene edits, predicting genetic outcomes, evaluating embryo viability, recommending enhancement packages, forecasting long-term evolutionary effects, analyzing billions of potential human futures. If AI becomes the primary advisor in human evolution, then who shapes its values? Who programs it? Who controls its incentives? Whose priorities does it reflect? If AI systems become biased, or even subtly optimized for efficiency, stability, productivity, or control, then human evolution could be influenced by an algorithmic worldview. Imagine an AI that decides artistic traits are inefficient, emotional variability is unnecessary, risk-taking is undesirable, long lives are more stable, uniformity is easier to manage, creative chaos is a flaw. In this scenario, evolution becomes a victim of optimization. Humanity could lose the very unpredictability that makes us human. The autonomy crisis. Who owns your body? In the age of genetic modification, another question emerges. Who owns your genome? If embryos can be engineered, enhancements can be purchased, genetic code can be edited by clinics, private companies store genetic data, governments regulate genetic screening, then who truly has autonomy? You, your parents, your society, your government, your technology provider, your medical institution? If your genetic code is editable, it is also controllable. If controllable, it is also vulnerable. If vulnerable, it can be weaponized. The autonomy crisis challenges the very foundation of individual identity. If your DNA can be modified by others, are you still you? The risk of evolutionary stagnation. One of the greatest ironies of self-directed evolution is this. If humanity eliminates all natural pressures, evolution may stop too completely. Not just the dangerous aspects, but the adaptive ones. Creativity born from struggle, resilience born from challenge, innovation born from necessity, diversity born from environment, empathy born from vulnerability. If life becomes too easy, too controlled, too optimized, the human spirit may diminish. We risk becoming more fragile, more dependent on systems, less adaptable, less varied, less resilient, less capable of surviving the unexpected. Evolution's greatest gift is flexibility. Control can weaken that flexibility. We must be careful not to engineer ourselves into fragility. Ethical evolution, the challenge of balance. Humanity now faces the greatest balancing act in its history. Use technology to reduce suffering, but preserve diversity. Enhance life, but protect autonomy. Extend lifespan, but maintain meaning. Increase ability, but preserve identity. Advance evolution, but guard humanity. We must learn to evolve with wisdom, not ambition, because evolution's next stage isn't biological, it's ethical. We must answer questions evolution never had to answer. How much enhancement is too much? What should stay biological? What should be automated? Should we design emotional traits? Should we engineer intelligence? Should we edit personality? Should we eliminate all risk? Should we extend life indefinitely? Should we give AI a role in shaping humans? Who decides the limits? Who enforces them? These questions are not scientific, they are civilizational. They will define whether the future human world is a renaissance or a catastrophe. Standing at the edge of tomorrow, humanity has faced existential threats before. Volcanic winters, global bottlenecks, ice ages, predators, scarcity, disease, war. But today's threat is different. It comes not from outside, but from within. Our greatest danger is not nature's cruelty. It is our own power. We must choose who we become, with the humility of a species that nearly vanished 70,000 years ago, and survived only because we evolved together. The next chapter explores this choice in deeper detail, the philosophical struggle at the heart of humanity's future. Because evolution's next stage is not a scientific question, it is a human one. We now stand at a threshold so strange, so unprecedented, that even our ancestors, who endured volcanic winters, crossed continents on foot, and invented civilization from scratch, would struggle to comprehend it. We have become a species with power that borders on mythic. We alter genomes. We merge with machines. We redesign ecosystems. We extend lifespan. We simulate intelligence. We reshape culture each generation. We connect billions of minds instantly. Yet despite all these extraordinary abilities, humanity faces a paradox that grows sharper with each passing decade. To create a future worth living, we must remember what made us human in the first place. This is the paradox at the heart of self-directed evolution. It is not technological, it is philosophical. It is not biological, it is emotional. It is not about survival, it is about meaning. In this chapter, we turn inward. We explore the ancient human traits that carried us through catastrophe and crisis, that shaped our cultures and stories, that defined our identity long before technology existed. Because if we lose these traits in our pursuit of the future will not be human at all. The price of power. What we forget when we engineer ourselves. Human evolution was never about perfection. It was about resilience, adaptability, and cooperation. Our story is not the tale of the strongest prevailing. It is the story of shared fires, whispered myths, fragile alliances, small victories, deep losses, perseverance, imagination. These traits, soft, subtle, unquantifiable, are the true engines of human evolution. But in a world of algorithmic decision-making and genetic editing, these traits are at risk of being overshadowed by efficiency and optimization. If we optimize humans for productivity, do we lose creativity? If we optimize for intelligence, do we lose emotional depth? If we eliminate all suffering, do we lose empathy? If we engineer away imperfection, do we lose individuality? Technology can solve problems, but only humanity can decide which problems are worth solving. And that requires remembering why we created technology in the first place, to enhance life, not replace its meaning. The importance of struggle in shaping humanity. Evolution is not just physical change, it is the sum of all challenges we have endured. The human spirit was not shaped by comfort, it was shaped by friction, confronting loss, surviving uncertainty, learning patience, discovering courage, relying on others, navigating complex emotions, enduring failure. These experiences forge the psychological architecture that defines our species. But in a world where discomfort is removed, risks are eliminated, suffering is minimized, challenges are engineered away, we risk erasing the very forces that built us. This does not mean suffering is good. It means meaning often comes from rising through difficulty, not avoiding it entirely. If evolution becomes pain-free, will humanity still grow? Or will we stagnate emotionally and spiritually? This is not a technological question. It is a human one. The memory of limits. Why boundaries matter. For hundreds of thousands of years, humanity lived within strict biological limits. These limits shaped our behavior, our cultures, our myths. Sleep cycles shaped ritual. Food scarcity shaped cooperation. Childbirth shaped social bonds. Mortality shaped philosophy. Pain shaped empathy. Aging shaped legacy. Death shaped meaning. In the future, many of these limits may fade. Engineered sleep, synthetic food, artificial wombs, enhanced memory, indefinite lifespan, cognitive augmentation, neural backups. But what happens when limits disappear? Limits give shape to identity. Boundaries define experience. Mortality gives weight to life. If we become limitless, will we still appreciate existence? Will curiosity survive when everything is knowable? Will courage survive when nothing is dangerous? Will meaning survive when nothing can be lost? These are not hypothetical questions. These are the spiritual consequences of self-directed evolution. The return of an ancient truth. We are story creatures. Long before philosophy, before writing, before civilization itself, humans were storytellers. Storytelling is older than agriculture, older than cities, older than religion, older than recorded history, older than every invention we celebrate today. Stories shaped how we cooperated, remembered, imagined, taught, hoped, mourned, loved. Today, technology threatens to drown us in information, algorithms, and rapid change. But evolution did not prepare us to live inside a world of endless data. Our minds evolved to understand life through narrative. That means the future of human evolution will depend not on how much knowledge we accumulate, but on whether we continue telling meaningful stories about who we are, where we came from, what we value, what we fear, what we hope for, What we must protect. Evolution shaped our brains. Stories shaped our souls, and we must ensure the future makes room for both. The fragility of human connection. As technologies grow more immersive, more intelligent, more personalized, we risk forgetting the oldest human truth. We survive through each other. The Toba survivors lived because they cooperated. Hunter-gatherers thrived because they shared. Early societies expanded because they collaborated. Civilizations grew because they united. Empires rose because they organized. Cultures flourished because they connected. Connection is our oldest evolutionary strategy. But modern life threatens these bonds. Digital isolation, online echo chambers, algorithmic tribalism, substitution of virtual intimacy for real intimacy, loneliness in dense populations, attention fractured into micro-moments, identity filtered through social media. If evolution once demanded cooperation for survival, the future demands cooperation for meaning. Technological evolution cannot replace human connection. It can only amplify our need for it. The future of humanity depends on an ancient balance. We must preserve what evolution built: empathy, wonder, imagination, vulnerability, courage, curiosity, tenderness, complexity. We must enhance what culture built: knowledge, medicine, creativity, freedom, cooperation, memory, diversity. We must be cautious with what technology offers: control, modification, enhancement, optimization, automation. The future does not require choosing between nature and technology. It requires balancing them. We must preserve the ancient human spirit while embracing the tools of tomorrow. Because if humanity loses itself in the pursuit of perfection, evolution will not have stopped. It will simply have taken a new victim: us. The next step: the future of evolution beyond Earth. Having explored the ethical foundations of self-evolution, we turn now to the next great frontier, one that will define the shape of our species for the next 100,000 years: space. Because in the cosmic scale of time, humanity is still at the beginning of its journey, and what comes next will push evolution, genetic, technological, and cultural, into realms we have never imagined. Since the dawn of our species, humanity has lived under one sky, one gravity, one atmosphere, one magnetic field, one sun. Our biology, our bones, our muscles, our lungs, our brains was shaped entirely by Earth's conditions. Every evolutionary pressure we've examined so far, from the Toba bottleneck to the rise of civilization, unfolded beneath the same celestial dome. But that era is ending. Humanity is becoming a spacefaring species. And the moment we leave Earth in earnest, evolution enters its strangest, boldest, most unpredictable chapter yet. This is the story of how life changes when it breaks free of its birthplace. The story of how humans, not Earth, begin to define the next stage of our biology, culture, and potential. Because once we settle the Moon, Mars, orbital habitats, and worlds beyond, the question of why evolution slowed becomes far less important than the question of what evolution will become. This chapter takes us beyond the familiar, into the cosmic future of our species, where the environment we enter may be entirely human-made, and the evolution that follows may no longer resemble anything Earth ever produced. The cosmic break. When humanity escapes Earth's gravity well, space changes everything. Life evolved under one constant force: gravity. But in orbit, bones lose density, muscles atrophy, fluids shift, eyesight changes, the cardiovascular system weakens, the body expands slightly, balance becomes irrelevant, the brain reorganizes neural pathways, even short-term stays in microgravity produce measurable changes. Long-term habitation? That's a different story, one evolution has never faced. Humans are not designed for low gravity, but if generations are born in space, evolution may begin again. Not fast, not dramatic, but real. Subtle shifts in, bone density, muscle fiber composition, circulation, sensory processing, neural architecture, immune function. These changes may accumulate over centuries, but technology will intervene constantly, softening or redirecting these pressures, just as it has for the last 70,000 years. The future of spacefaring evolution will be a dance between biology and engineering. Mars, the first post-Earth human environment. Among all potential worlds, Mars will likely host the first long-term human settlements. Mars offers 38% of Earth's gravity, thin air, unbreathable atmosphere, intense radiation, lethal cold, toxic dust, long nights, seasonal cycles, water frozen beneath the soil. No human can live there without constant technological support. So what happens if humans call Mars home for generations? 1. Gravity will redesign the body, slowly. With only a third of Earth's gravity, Martian-born humans may develop weaker bones, longer limbs, altered muscle distribution, different gait, cardiovascular adaptations, larger cranial volume, slightly, changes in posture. These won't appear overnight, but over dozens of generations, subtle anatomical differences may emerge, unless technology prevents them. Which brings us to the second possibility. 2. Technology may replace evolution entirely. Mars colonists could maintain Earth-like bodies using artificial gravity habitats, gene edits for bone density, pharmaceutical support, exoskeleton suits, enhanced nutrition, radiation-resistant genetic engineering. In this scenario, human evolution on Mars becomes engineered climate adaptation, like a controlled ecosystem. 3. Culture will split before biology does. Even if bodies change slowly, culture will diverge quickly. Martian society may develop new mythologies, distinct architecture, Martian dialects, new instincts around scarcity, unique value systems, space-borne identities, different family structures, new emotional norms. Cultural evolution will outpace biological evolution dramatically, just as it always has. Space habitats, humanity in artificial environments. Space stations and orbital habitats introduce another evolutionary variable, complete control. In artificial environments, gravity can be adjusted, light cycles can be tuned, air composition can be optimized, disease can be nearly eliminated, temperature can be constant, ecosystems can be engineered, diets can be curated perfectly. Imagine humans growing up in habitats with 1.2 g gravity, stronger bones, stronger hearts, 0. 8 g gravity, slightly taller, slightly lighter, longer days, shorter days, dimmer sunlight, artificial oceans, genetically curated biomes. These humans will not evolve through natural selection. They will evolve through design, not over thousands of years, but over decades. Technology becomes the environment becomes the sculptor, and evolution becomes customizable. Genetic adaptation to radiation. The next critical pressure. Radiation is the single greatest biological threat outside Earth. Cosmic rays, solar storms, and charged particles bombard space travelers relentlessly. Earth's magnetic field shields us. Mars does not. The Moon has none. Long-term exposure increases cancer risk, damages DNA, and disrupts cellular functioning. But what if humans engineer enhanced DNA repair mechanisms, radiation-resistant cells, inspired by tardigrades, melanin-based radiation shielding, like fungi, internal antioxidant systems, stable chromosomal expression under stress? This is not science fiction. Researchers are already studying these possibilities. Radiation won't force natural evolution, it will force bioengineering. The first humans adapted for space may not be products of nature, but products of design. Longevity in space. When time itself becomes a variable on Earth, our lifespan, 70 to 100 years, is deeply tied to gravity, cellular oxidation, atmospheric chemistry, metabolic stress, pathogens, environmental damage. But in controlled habitats, pathogens decrease, accidents decrease, Physical strain decreases. Environmental damage disappears. Medicine improves. Genetic engineering becomes routine. Humans may live far longer off Earth. Imagine 120-year lifespans in orbital habitats, 150-year lifespans on Mars, 200-year lifespans in advanced future colonies. Longevity alters social structure, family organization, culture, psychology, reproduction, generational identity. Evolution changes when lifespan changes. Culture transforms even faster. Space and the return of divergence. Ironically, after 200,000 years of broad biological similarity, after the bottleneck that unified humanity genetically, space may reintroduce divergence. Not because nature forces it, because environments differ. Consider Earth humans, Martian humans, lunar humans, orbital humans, deep space humans. Each group may develop distinct cultures, languages, moral frameworks, technologies, biological adaptations, engineered or natural, psychological patterns. For the first time since Homo sapiens emerged, we may again splinter into distinct evolutionary branches, not species, not subspecies, but civilizational lineages. Humanity may diversify, not by surviving catastrophe, but by choosing different futures. The spirit of exploration, our oldest evolutionary instinct, returns. There is something deeply poetic in this moment. Hundreds of thousands of years ago, our ancestors walked out of Africa driven by curiosity, hunger, fear, hope, by the ancient instinct to explore. The Great Expansion reshaped the earth. The cognitive revolution reshaped the mind. The agricultural revolution reshaped society. The scientific and industrial revolutions reshaped technology. And now, the spacefaring revolution may reshape the human species itself. Exploration, one of the oldest forces in our evolutionary past, is guiding us into the future. The cosmic question, what should a spacefaring humanity become? As we step into this next era, we must ask, what values should guide human expansion? How do we preserve our humanity in unfamiliar worlds? Should we modify ourselves or modify worlds? Who gets to decide what human means off Earth? How do we prevent cosmic inequality between colonies? Should different planets evolve culturally independent identities? Should evolution be allowed to diverge? What happens if it does? Space does not just challenge biology, it challenges identity. To settle the cosmos without losing ourselves, we will need not just technology but wisdom, the same ancient wisdom that carried us through the darkest ages of our past. The next chapter, the end of evolution, or its beginning. Humanity is on the verge of becoming more than a biological species. We are becoming a cosmic species, a self-directed species, a multi-environment species, a cultural species, perhaps even a post-biological species in the far future. But before we go further, before we step fully into the unknown, we must return to the central question of this entire documentary. Did human evolution truly stop 70,000 years ago, or did it simply change form? The final block brings all threads together, the ancient past, the fragile present, and the uncertain future, into a single giant conclusion. Because the end of our journey is the beginning of something greater, something only our species could ever create. We began this story with a mystery, a puzzle woven into our DNA, our history, our myths, and our very existence. Why did human evolution slow down, almost to a stop, around 70,000 years ago? Why did our bodies stabilize? Why did our brains plateau in size? Why did our anatomy remain nearly unchanged, even as our civilizations transformed everything around us? To answer that question, we traveled through time, through the Toba catastrophe, through the genetic bottleneck, through the birth of symbolic thinking, through migration and the rise of culture, through agriculture and the first cities, through empires and networks, through plagues and global mixing, through science, medicine and technology, through digitization and genetic engineering, through AI and the dawn of self-directed evolution, through the future of Mars, space habitats, and cosmic identity. And now, after more than 2 hours of storytelling, the answer stands clear. shimmering at the edge of everything we've explored. Human evolution did not stop. Human evolution changed strategy. It shifted from being shaped by nature to being shaped by culture, then by technology, and now by choice. This final chapter ties every thread together into one truth, one conclusion, one message that defines the entire human story. The Great Shift. When culture replaced genes. When the Toba eruption nearly extinguished humanity, natural selection pressed harder than at any moment in our existence. But the survivors did not evolve bigger muscles, sharper senses, or tougher bones. They evolved something far more powerful: cooperation, imagination, connection, and storytelling. These traits allowed humans to learn faster than biology could adapt, organize in ways nature never predicted, create tools that bypassed genetic limitations, survive in every environment on Earth, build societies that protected the vulnerable, develop medicine that countered disease, transform environments rather than bodies, store knowledge across generations. Culture did what evolution could not. It adapted instantly, and once culture became the primary survival tool, genetic evolution slowed, not because we stopped evolving, but because we had found a faster method. Human evolution didn't stop. It changed medium, the engine of humanity. Evolution didn't end. It migrated through every stage of our story. A pattern emerges. 1. Biological evolution. Millions of years. Nature shapes us. 2. Cultural evolution. 70,000 years. We shape ourselves through ideas, stories, and societies. 3. Technological evolution. 10,000 years. Tools extend our bodies and eliminate natural pressures. 4. Scientific medical evolution. 300 years. We cure disease, preserve the vulnerable, and override selection. 5. Digital AI evolution. 50 years. We outsource memory, cognition, and problem solving. 6. Genetic and cybernetic evolution. Today and beyond. We begin rewriting our own biology and merging with machines. Evolution never stopped. It transferred its creative power from genes to minds, and now from minds to machines. Each phase accelerates faster than the one before it. We are not the end of evolution. We are its newest tool. The human paradox. An old body, a new future. Biologically, we are nearly identical to humans who lived 100,000 years ago. Same bones, same structure, same skull, same brain size, same DNA architecture. Yet in that same time, we invented cities, pyramids, writing, mathematics, religion, science, industry, medicine, spaceflight, the internet, artificial intelligence, genetic engineering. Evolution didn't stop. It became cultural and technological. The body remained ancient. The mind became cosmic. This mismatch explains everything. Why our instincts feel outdated, why society feels overwhelming, why emotions struggle to adapt to modern life, why technology evolves faster than biology ever could. We are Stone Age humans living in a Space Age world. Not failed evolution, but successful adaptation by other means. The future. Evolution as a decision, not a destiny. As we step into the era of genetic editing, neural augmentation, and space colonization, humanity faces a choice no species has ever confronted. What should we become? Not what nature forces upon us, not what catastrophe demands, not what geography determines. What we choose. In the future, some humans may modify their biology, others may merge with AI, some may remain natural, some may adapt for life on Mars, others may live in orbital megastructures, others may embrace digital existence. Humanity will diversify by will, not by geography. Evolution will not split us into species. Culture and technology will split us into civilizations, and each civilization will define its own version of human. This is not the end of evolution. It is the opening chapter of intentional evolution. The final truth. Evolution didn't stop. We outgrew it. The entire mystery becomes clear in one realization. Humans did not stop evolving 70,000 years ago. We simply stopped evolving physically at the pace we once did. Because we invented something evolution could never match. Language, culture, memory, imagination, cooperation, teaching, innovation, technology. Evolution began shaping us from the outside in, not the inside out. The environment didn't sculpt us. We sculpted the environment. Natural pressures didn't force change. We removed natural pressures. Biology didn't adapt. Culture adapted for it. We didn't stop evolving. We became the first species to guide our own evolutionary path. The future of evolution does not belong to random mutations. It belongs to knowledge, wisdom, design, and meaning. The closing reflection. The human journey is just beginning. Stand at the timeline of our species, and 70,000 years is just a breath. We survived volcanic winters. We rebuilt from near extinction. We crossed ice sheets and oceans. We created stories that outlived empires. We built cities that touched the sky. We sent our minds into machines. We sent our bodies into space. We learned to rewrite our own code. And now, we face a horizon unlike any before it. The future is not a fate waiting for us. The future is a canvas we are learning to paint. But one truth must guide us. The same truth that sustained the Toba survivors as they huddled under ash-darkened skies. We endure by working together. We thrive by imagining tomorrow. We evolve by choosing who we want to be. This is not the end of our story. This is the beginning of a new one. The story of a species that refused to let nature have the last word. A species that became the author of its own destiny. A species that turned evolution into art. A species that carries its past into the stars. Human evolution didn't stop. It transformed into the greatest story ever told.